I am Pratap, and this course is a accumulation of my expertise on Python programming, from which I would like to help the new beginners and also the expert out there to gain more knowledge about Python so that they can work in the real life scenario. So in this section, we'll go through basics of Pythons. We'll learn about variables, we'll learn about data types, we'll learn about data structure, we'll learn about object-oriented programming, and so on. So let's get started. So in this section, we will be recapping our Python concept. We'll learn about variables, we'll learn about data types, we'll learn about data structure, we'll learn about the conditional operators, we'll learn about loops, we'll learn about functions, we'll learn about object-oriented programming, we'll also learn about type hinting, which was introduced in Python 3.5. We'll learn about exceptions, we'll learn about built-in exceptions, user-defined exception. We'll also learn about the mutability, we'll learn about the data types which are mutable, and also learn about mutable data types as a default parameter function and why it's a bad idea. So in this section, we will be starting from a basic to an advanced level. And once you complete this section, I assure you, you will be getting all the gist of this Python concept, which will help you build the core of your principle of Python. And you can use those concepts in the future to build amazing projects for yourself and for your organization. So welcome back. In this lecture, we'll learn about variable in Python. So let's say we have x equal to 15. So let's understand what's a variable. So a variable is nothing but a container for storing data values. So here we have a value of 15 and we are assigning this 15 to what? We are assigning to this x. So basically x is a variable and it's a container and it's storing this value 15. Okay, so this way we are creating a variable, and Python has no command over declaring a variable. So a variable is created the moment you assign a value to it. So when I assign any value to it, so a variable is created. So I can say x equal to 15 and I can say y equal to Pratap, or I can say z equal to learn with Pratap. So you can see when I write a string here, you can see that I have a single quote and a double quote. So if I start with double quote, I should end with double quote, or if I start with a single quote, I should end with a single quote. If I say this way, so this will throw an error. Okay, so this was just a note. So let's print x, so let's print y, and let's print z. So let's run this code, and you can see that we have 15 Pratap learn with Pratap. So when we print all this, so variable do not need to be declared with any particular type and can even change type after they have been set. So here I say z equal to Pratap. I can go ahead and change this z to a number, let's say 9, and now if I print, you can see the output is 9 now. Okay, and also you can also cast a value. I say z equal to, I can cast this is a number, okay, this is an integer. I can cast it to a string by doing like this, and if I say, let me just say type, and you should see here this is a string. So you see this is a string, but the value of z was 15, right? So you can cast it. So if you want to get the type of the variable, you can do by using this type function and then passing to it. Okay, we'll learn more about data types and casting data in this tutorial. So as I told you, like we have talked about the single quote or double quote. So if you are using single quote, you should close with the single quote. If you're opening with the double quote, you should end it with the double quote. Okay, and Python is case sensitive. So if I say a equal to 10, and I can also say a equal to 16. So Python treat the small case a and the capital case a differently, and these both are a different variable. Okay, so let's learn about data types in Python. Data types in Python. So we have different data types. So let's start with str. So there's a string, and we have in number numeric type, which is called integer or float or a complex. Also we have list, tuple, and range. We have a dictionary, and then we have a set, we have Boolean, and we have none type. So these are the different types of data types which we have in Python. So if you want to get the type, what we can say is, let's say x equal to, if I say 10, and if I print type x, then if I print this, you should see I have a type of integer, so which I have already demonstrated earlier. So in Python we can format a string in multiple ways. So let's say we have a variable name equal to Pratap, and let's say we have a greeting variable, and this will say hello Pratap. If we want to format this string to say, let's say print greeting, and I want to run this, so let's say if you run this, so we get here hello Pratap. So let's say after this I want to assign this name to, let's say David. If I want to run again, but still I get Pratap here. So how can we fix this? So in order to fix this, what we can use is here an f string in Python. So we can put something here. So this f string should be in front of this quotation, and we can keep this inside the curly bracket. And now this curly bracket inside this string accepts a variable. So here in our case it will be name. So let's run again, but we still have the problem which we encountered earlier, right? So we're not able to assign the name again to David. So to do that, I think what we could do is we could say David here and reassign again, or there is also another better way to format a string. So let's say we can say greeting2 is equal to, we could say hello, and let's say this way. So here, remember this, we don't have any f here, and now I can say print greeting2 dot format. So I can pass the variable here. Let's just say I here Pratap. Okay, so if we run this code, you'll see we have here hello Pratap. Now if I change this to David, let's say David, then here we have hello David. Okay, so we can have this multiple formatting. Let's say hello and today is Tuesday. So if I say, I can pass multiple arguments here. Let's say David, oh sorry, it should be curly bracket here, and let's say Monday. So if I run this code, you will see that hello David, today is Monday. Let's copy this line and let's paste again. Let's say here Pratap, and let's say here Tuesday. So we get here hello Pratap, today is Tuesday. So we can have as many as formatting or a placeholder as possible here. We can have thousands of that, but for that we need to call this greeting2.format, this function, and pass the arguments as we required. So here this greeting2 requires two templates. Now let's see what happens if I just pass one single template. So let's run this. So here in this case we get an error. It says that this string requires at least two arguments, but you are sending only one. So in this case we have to, it will throw us an error if we send only single. So this is how we work with string formatting in Python. So today we'll learn about user input. So let's have a variable input. Let's say user input is equal to, so in order to get an input from the user, we have a function input in Python, and this input will take a argument of prompt, which will basically what is your name. So basically what is an input? Input is a function just like print. It will take some string and it will act as a prompt. So it reads the string from the standard input and it will strip the trailing new line. Okay, so and let's print the user input. Print user input. So if I run this, so you see here it asks me for the name. So this is a prompt. It's asked me for an input. So it's asked me what is your name. Let's say my name is Pratap. So if I enter, so now the value of user input is Pratap. So basically user input is nothing but a variable. We're assigning the variable whatever we're getting from the input. So that's why now the value of user input is Pratap. Okay, so let's do some math calculation. So let's say we have a number and this will be an input. Let's ask prompt square of which number. Let's say this, and here what we're saying, we are assigning like we have a variable number. You're assigning this number with the whatever input we're getting from this user, and we want to do some calculation, mathematical calculation. Let's say number into number. So let's run this code and you will see let's comment this, so we don't need any more. Let's run again. So square of which number? I want to find the square of 10. Like we are getting an error here. Why? Because we can't multiply the sequence of non-integer of type string. So we should always remember that whatever we get from this input is always string. So in this case we need to typecast. We need to cast the type. So let's say this is user input and our number would be nothing but we'll cast our user input to an integer, and it will be an user input. So now if I run this code, let's say 10, so now I get 100. So what we should note is whatever we get from this input is always string. We need to cast it. But now if you see this, this is very not beautiful. So let's try to format this. So how can we format this so that we can see an output like the square of number is something like that? How can we do that? Please pause and try it by yourself. So okay, so I think we are able to do this. So using our previous knowledge, we can use our f string and we can say the square of, and here we can say number is, and we can say here number into number. So now if we run this code, let's run this code and let's say we want to find square of 11, and it said the square of 11 is 121. Today we'll be writing our first Python app. So here we'll be using our existing whatever we have learned till now and up until now, and we'll be building Python app. So what we'll be building? So let's say we'll ask a user about his age and then we will find how many days old he is. Okay, so how can we do that? So let's say user age is equal to input and how old are you, and then now what we have to say is we need to convert this user age to a number. Let's say user age num equal to int and user age, and now we can say days old is equal to, so it is very simple. Let's say we have 12 months in a year and we have 365 days in a year, and then the user is user num age, user age num. So and then we can say print you are, and we can use f string here, and days old, we can say this. So if we run this code and let's say I am 25 years old and it says I am, but what is this? I don't understand, right? We need to restate days old. Let's format this way and let's run again, and let's say I am 25 years old and it says you are 109500 days old. And if we want to find months old, we can also say, let's say print and let's say months old. We can change this. Let's say this is months old, and you can simply remove this 365, and I can say months old. So let's run this code. So it will ask me how old am I. So I am 25 years old, and it says I am this much days old and I'm 300 months old. So in today's session, we'll learn about list, tuples, and set. These are the three different data structure of Python. So here we can store multiple elements inside a single variable. So let's get started. So let's say we have a variable L, which is equal to a square bracket, and then let's say learn, and then let's say we have another item with, and with, let's say we have a third item called Pratap. Okay. So if you see here, we have a variable L, and we're assigning this L with a something called this square bracket. So we should always understand this anything that has a square bracket here is a list, and here we can say that inside this list we are having three items, that is learn, with, Pratap. And let's say we want to access the first item, let's say learn. So how can we do that? Let's say it should be print L of 0. So what is this 0 and what is this? In programming, we call this as a subscript notation. In programming, an item in any list is stored as an index. So this is at index 0, this is at index 1, and this is at index 2. So now if I run this code, we can see that we are getting learn here, right? That means we are trying to get the element at index 0. So let's learn about tuples. Tuples, we have equal to, and then this is kind of same with our list, learn, with, Pratap. But you see the difference here. In list we are having a square bracket, in tuple we are having round bracket. So the main difference between the list and the tuple is, in a list we can change the elements, we can update them, but in tuples we cannot change them. Tuple is immutable. And let's say we have the same as set. Let's say s equal to learn, with, Pratap. So here in set you can see that we have an element inside this curly bracket. So these are the main differences between the list, tuples, and set. A list is inside a square bracket, a tuple is inside a round bracket, and in a set it's inside a curly bracket. So in list we can have duplicate elements, we can update them, we can mutate them. In tuple we cannot mutate them, it's immutable, and in list we cannot have a duplicate elements. And another point about here is, in list we maintain an order, in tuple we also maintain an order, but in set we don't maintain any order. These items are placed randomly. So let's add print in each of the statement. Let's say print t. Here I want to print the first element. I can say print t of 0. If I run this, you can see I get learn. But here I can say, for the set I can say s of 0, because s does not have any index. So you see, set object is not subscriptable. Also in list we can add item to the list. So we can add an item to the list. So how can we add an item? Let's remove this. We can say l.append. So let me append today, and let's print the list. So let me comment all this, and let's run. So you see here in the list we have appended a new element in the list, which is today. Okay, so let's try the same for tuple. Let's say tuple dot append, and let's say today. Let's run. Sorry, append. So let's run. So it says that tuple object has no attribute append. That means in tuple we cannot mutate the tuple, we cannot change the value, right? So that's why we don't have append function inside this t. So we'll learn about these functions and all, like t dot append. We'll learn more about this in further sections. So let's try the same for our set. Let's say set dot. So but here in the case of set we don't have append but we have add. So in set I can add, let's say today, and let's print the set. So we cannot do this. Let's remove this. So let's run this. So we see that we added the today in the set, and if you see, the order is not maintained. So we add this today at the end of the set, but you see here we have today Pratap with learn. So it is randomly added. Okay. So we also can remove an item from the list. So let's try to remove. Let's say remove, and I want to remove Pratap. So we'll be able to do that in list. Let's print the list. So we see now we have only learn with, and there is no more Pratap. And also let's do the same with tuples. So you see here we don't have any function here. So in case of tuple we cannot do that because tuple object does not have an attribute remove. So we cannot remove an element from the tuple because tuple is immutable. Okay. And let's do the same for set. So we can remove from set. And if I say print s, so you see we have with learn and we don't have Pratap anymore. And also in set we cannot store duplicate element. Let's say I want to store Pratap again, and let's print s. So you see we have only single Pratap, though we added multiple Pratap here. So that means in set we cannot have duplicate elements. In tuple we cannot mutate them. In list we can add or remove any elements. And list and tuples maintain orders, but set doesn't maintain any orders. So these are very basic concept of list, tuples and set. We'll learn more about them in the upcoming section. So in today's session we'll learn about advanced set operation. So let's get started. So as we have learned, what is a set? A set is an unordered collection data type that is unindexed, it is mutable and has no duplicate elements. And as we say, sets are created using curly braces. I can say s equal to learn with Pratap. So this is a set. So what is a set? So a set start with curly braces. Set is an unordered collection data type that is unindexed, that's mutable and has no duplicate elements. Okay, so how can we create a set? We can create a set by using this curly bracket. So it's simple. Let's print this set. Print s. So you see we print the set. So learn with Pratap. Okay, or we can use the set function and create from an iterable, example list, tuple, string, etc. Or we can say, so let's say my set equal to, we can use this set, this one. Okay, and then we can use even a list. So let's say learn with Pratap. So if I print my set, so in this case also we'll get learn Pratap with. So it is unordered. Since a set is unordered, so we are getting here unordered output. Okay, so like we have this set. So let's learn how to add an element to this set. So what we can say my set dot add, and let's say Monday. And if we print this set again, we can say Monday in the set. Or we can remove an element from the set by using my set dot remove, and we can say learn, and you can print. So you see we don't have learn anymore here. Okay, so this is very simple. So we can also use pop. Let's say my set dot pop, and let's run this. You see we have only with and Monday. So what happens here? Let's comment this line first, so to understand how the pop works, and let's run. So here we have learn with Pratap, and you see one of the item is being removed. Okay, pop returns and remove a random element. So it doesn't have any definite element, it just remove a random element. So if you remember in set, we can find, let's say, so let me comment all this. So let's leave it. Okay, so let me comment this and let me comment this, and let's say we have cities, and we can say Lalitpur, we can say Pokhara, and we can say Kathmandu. Okay, and we can say another, we can say cities too, or we can say Hetauda, we can say Pokhara, and we can say Birganj. Okay, let's say using these two sets, we want to find a combination of these two sets. So what can we do? We can say series dot union, and you can pass cities too, and let's print this. So you see we have here Kathmandu, Lalitpur, Hetauda, Birganj, Pokhara. And as you can see from here, we had Pokhara multiple times, but when we combine this, when we find the union, we only get Pokhara once. Okay, we can also have an intersection. Intersection means an item that is present in both the set. Okay, so let's say print cities dot intersection cities 2. So if I run this, we should get only Pokhara, because Pokhara is present in both the sets. Okay, we can also find the difference between those two sets. So to do that, we have print, we have cities dot difference, and you can say cities 2. So let's comment these two line, and let's run this code, and you can see the difference between these two sets is Lalitpur and Kathmandu. So why Lalitpur and Kathmandu, and why not Hetauda and Birganj? Because we are finding the difference between this set over this. That means if this is present in the second set, we should exclude it. So in this way, so in this case, Lalitpur is not present there, so we took it. Pokhara was present there, we remove it, and Kathmandu was not present there, so we add it. So this way we get Lalitpur and Kathmandu. Okay, so these are all the basics of these advanced sets. So we have union, we have intersect, we have difference. So we all come to know about the difference between all these set operations. So in this session, we'll learn about Booleans in Python. So let's get started. So Booleans in Python represents either true or either false. Okay, what's a Boolean? So Boolean can have either true or either false. It will be either 0 or either 1. Okay, so it just represents two values in Python, true and false. So in programming, you often need to know if an expression is true or false. So you can evaluate any expression in Python and get one of two answers, true or false. So let's take an example. Let's say print 1 less than 5. So is 1 less than 5? Yes, it is. So we should get true. And let's say print, we can say 10 greater than 11. So in this case we should get true, and in the second case we should get false, because 10 is not greater than 11. So let's run this. So it's false. So we can also check the Boolean by using, let's say, print, and we can say bool. So in Python, the keyword for Boolean is bool. So we can use bool, and we can say 10. So when we print this, what should be the value here? So please pause and guess the answer. Okay, so I hope you're able to guess it right. The answer here will be true. Why true? Because 10 is not 0. So if I say here print bool 0, then what should be answer here? So let's run this. So it's false, because 0 is false. But if I say bool of 1, then this will be true. So you see. Also, we can check this on a string. Let's say print, let's say bool, let's say Pratap. If I run this, this is also true. So let's comment all this. But if I say bool of empty string, so in this case I will get false, because empty string is empty, it's nothing, that's why it's false. And if I say another thing is, what we can check is print bool of none, and what should be the value of this? It will be always false, because none is false. So in Python, most values are true. Almost any value is evaluated to true if it has some sort of content. So in this case, this had some content, so it evaluated to true. So in this case, it doesn't have any content, so it evaluates to false. So any string is true except empty string, as I told you here, and any number is true except 0, as I have shown you here. So any list, tuple, set, and dictionary are true except empty ones. So let's say print bool, and if I say empty set here, so we get false. So let me comment all this. So it's false. But if I say here Pratap, so this time this is not false anymore. I should get true here. Okay. So there are not many values that evaluates to false except empty values, such as I told you, it should be empty, empty tuples, empty list, empty string, and empty sets. So the number 0 and the value none, and of course the value false is also false. So I can say print bool false. So this should also be false. So in this section, we'll learn about if else in Python, Python conditions and if statements here. So in Python supports the usual logical condition from mathematics. So we can have equals, that is this. We can have, like, to be specific, I can say a equal to b, or not equals, that will be a not equal to b. So here this exclamation marks means not. If this is equal, then here not means not equal. Okay, and less than, so less than will be a less than b, or we can have less than or equal, that will be a less than equal to b. We can have greater than, so which is basically b greater than c, and lastly we can have greater than or equal, which is b greater than or equal to c. So these are all the logical condition that Python supports. So this condition can be used in several ways, most commonly in if statements and loops. So an if statement is written by using if keyword. Okay, so I can say, let's say we have a number a equal to 10 and then b equal to 30. Okay, and we can have if, let's say a is greater than b, then in that case we can say print a is greater than b. So let's run this code. Here it doesn't print anything because a is not greater than b. But if I say a is less than b, then in that case it will say a is less than b. So let's run again. So if a is less than b, then so in that case it prints a is less than b. So here we have two variables a and b. So a had some value of 10, b have a value of 30, and then in this if condition we are checking if a is less than b. If a is less than b, then we are printing a is less than b. And if you remember, in Python this indentation is very important. This won't work because an if indentation should always be inside one tab. Okay, and we can also have elif. So what is an elif? We can say elif a equal to b, then print both numbers are equal. So let's say a and b are same. If they are 10 10, then let's run. So in this case, we get both numbers are equal. That means the code goes from this way, from like top to bottom. It first check if A was less than B. No, in this case it was not less. Then it skipped the code and it goes to this block, and it checks again if A was equal to B. So in this case, A is equal to B, which is 10. In this case, it goes and print both numbers are equal. And lastly, we have else. So what is else? So the else keyword catches anything which isn't caught by the preceding condition. So this, it will check for this condition. If it doesn't match, it will go to this condition. If it doesn't match also this one or any other elif, then it will go to else condition. So here, let's say print A is greater than B. So let's say if I have here 11, so let's run this code. So that means here we have A equal to 11 and B equal to 10. So firstly the code will go here. It will say 11 is less than 10. No. So it will go here. 11 is equal to 10. No. Then it goes to else and it prints here. So it doesn't check anything further. But what we can say is we can have multiple elif. Let's say A plus 1 equal to 5. Then we can say print addition of 1 in A equals B. So it will go and check this condition. It doesn't match, it will go to this condition. It doesn't match, it will go to this condition. It doesn't match again. And lastly, if it doesn't match any preceding conditions, then it will go to this else statement. So like we're having here a very long if statement. We can also have a shorthand else if. Let's say if A is greater than B, then we'll say print. So we'll say print A is greater than B. So let's run this code. So in this case, we say that A was greater than B. So therefore, this gets printed. Okay. So this is a short. What is this? This is shorthand if. We can also have shorthand if else. If else, which is also simple. Let's say print. Let's say A if A greater than B, else print B. So let's run this code. So we get here A. So how this statement reads, it will print A if A is greater than B. Otherwise, it will go and print B. So you can read Python code as naturally as human readable script. Let's say, would say like if we were like to explain this code to someone, we'll say print something if something is matches, else do this. Like get a cookie from shop if the shop is open, else get a juice from another shop. So it's as simple as that. So we can also have not. Let's say if not A greater than B, then print A is not greater than B, and you can say else print A is greater than B. So if you run this code, you can say A is greater than B here, this one. So not means it will go and check this first, A is greater than B. So in our case, A is greater than B, true. And not means negation of true, which means if it is true, it will be false. If it is false, then it will true. It will be true. So it will negate. Then in that case, it will say A is greater than B, because this was true. It negates it. It becomes false. So if false, that means it will go to the else, and it will print this one. So in today's session, we'll learn about the in keyword in Python. So let's get started. We can use this in keyword against any type of these iterables. So let's say iterables like list, we can use in tuples, or we can use in set, or we can use in string. So let's say we have a list, my list, and let's say it's equal to learn with Pratap, and let's say we have a set, my set equal to same thing, learn with Pratap, and also the same thing for my tuple. And as you would know, a tuple should be inside a round bracket. So let's say we have a list, we have a set, and we have a my tuple. And in Python, we can use this in keyword to check if something is inside this list or inside this set or inside this tuple. So using this in keyword, we can check if the item is present in the list or in the set or in the tuple. For example, let's say we can do print learn in my list, and let's run this code. So you can see we get true. Or let's say here Mumbai, and let's check. So in this case we get false. So here should be learn, and here we'll say my set, and we'll do the same again for my tuple, and let's check. So you can see we have learned in each of them. We have in the list, we have in the set, we have in the tuple. So that's why we're getting true, true, true. So how does this in keyword works? So basically it will take this and it will go and check if this element is present in the list or not, if this is present in the set or not, if this is present in the my tuple or not. So if this is present, then it will return true, else it will return false. Let's say here I can say hey. Since hey is not present in tuple, then we should get false. We can also use this in keyword for a string. Let's say my name equal to Pratap. I can say print ap in Pratap. So if you run this, we'll get true. Let me comment all this so that you'll get the clear picture. So in this case we get true. But if I say here pap, so we get false, because it is checking for the substring. So it will go and search pap in this string. So we don't have any substring pap here. So in this case it will not give result. So if I say tap, then in this case it will work because we have a substring of tap in this Pratap. Okay. But if I say pra, this will not be true because this p is in lowercase and this p is in uppercase. So Python uses this character as different characters. So it is case sensitive. So we'll learn more about in keyword with if statements. So see you in another section. So in this session, we'll learn about how to use the in keyword with the if statement. So let's get started. So here, let's say we have a list which consists of some programming languages. Let's say Python, JavaScript, Java, Go. And we'll take an user input. Let's say favorite language. So which would be basically, it should be input. And we'll say, what is your favorite language? And based on the user input, we will do some operation. We'll say if favorite language in my list, we'll say print your favorite language is present, else print no languages found. Okay, so here we have a list. So in this list we have a list of programming languages like Python, JavaScript, Java, Go, and then here we are taking a user input. We're asking what is your favorite language, and then based on the language we're checking if this favorite language is in the list. If the favorite language is in the list, then we're saying your favorite language is present, else no language no languages found. Okay, so let's run this code. So here let's say Python, but I wrote Python here, but it says oh no languages found. So why is that? So that is because the string which I've entered here, Python, it has a P in small letter, but my list, the Python in my list is in capital letter. So that is the reason why the string doesn't matches, as I told you in the previous section. So here, if I say Python in capital now, so it says your favorite language is present. Okay, so this is one way we can use if with in. So if this is in this list, or it can be a dictionary, or it can be a set, or it can be a tuple. So if this is in this, then we'll do something else, we'll be doing something. So in today's session, we'll learn about loops in Python, and we'll learn about for loop in Python. So let's get started. So what is a loop? So let's say if I want to show a message 100 times, learn with Pratap, I want to print it 100 times, then in that case, you can use a loop. So in computer programming, loops are used to repeat a block of code. Okay, so in Python we have two types of loop. So one is a for loop and the other is a while loop. Let's learn about for loop in Python. So let's say we have a name Pratap, and I want to print each character of this name. So what I can do is for char in name, and I can say print char. So let me just run this code so that you get an overview. So you see here we have each individual character of that string. So this is how Python for loops works. So it tests a condition. If the condition is true, it will go to the body of the loop. If the condition is false, then it will terminate the loop. So in our case, we are iterating over the range of this string. This loop initially starts with the value Pratap p in it. It gets p from here, it's true, and then it will enter the body. So here it will print the character p, and then it will go back here, and this time, so in the next iteration, the value of char will be r. Second iteration. In the third iteration, the value of char will be a. In the fourth iteration, the value of char will be t, and then in the next iteration, the value of char would be a, and in the last iteration, the value of char would be p. Okay, we can use the loop to iterate over a list, tuples, or string. So here I've used an example of string. So I can, let me just edit here, like for loop is used to iterate over sequences such as list, tuples, strings, etc. Okay, so we should all know this. So here in this case, I was using an example of string. So in the second example, I can use, like, let's say I have a list of languages. And let's say we have here Go, we have here Python, we have here JavaScript. So I want to print each languages. So how can I do that? It's very simple. Let's say for, let's say language in languages, and I can say print language. And if I run this code, you can see I have Go, I have Python, I have JavaScript. So just let me comment this part so it's not required anymore. Let's run this code again. So you can see we have Go, Python, and JavaScript. Let's understand like what exactly is happening here. So in the above example, we have created a list called languages, and it has 3 items in it. Initially, the value of language would be Go, and it is set to the first element of the array, which is Go. And the print statement here, it would print the value of language, which is currently Go. In the second iteration, the language will be updated to Python. It will use the next element, and the print statement will be executed again. Okay, so this way a loop runs until the last element of the list is accessed. So let's learn more about the for loop syntax. Syntax of for loops is basically, you can say for some value in sequence. And here we can run the statements. Here we'll be iterating over what? a sequence. What is a sequence? In Python, we have list, tuples, or string. For each iteration, we will have a value. For in this case, we have assigned a variable called language. Here I'm saying val. So for every value in the list or in the sequence, we'll have a variable and it will have the value assigned from the list. And here val is accessed each time sequences on each iteration. The loop continues until we reach the last item in the sequence. Okay, so these are the basic example of for loop. Also, we can use for loop with Python range. So let's say we have values equal to range of 10. So range is a Python built-in function. It's basically range object. So it will give us, so when I say range of 10, then it will give me a range from 0 to 9. Like if I print values, you can see. Let's run this code. So you see we get a range of number from 0 to 10. So here, what you can see is here inside the range I've given 10. So it defines a range containing values 0 to 9. So in Python, we can use for loop to iterate over the range. It's very simple. Let's try this. We can say for I in values, and we can print I. So let me comment this again. Let's save and let's see. So when I iterate over range, so I will get, for the first iteration I get 0, for the second iteration I get 1, for the third iteration I get 2, and so on. So we can use for loop or ranges too. Also, we can run a loop without accessing the item. So like, let's say we have a values here. So instead of printing the I, what I can say is, I can say my name is Pratap. My name is Pratap. So in this case, what would be I doing is, like, I'm not using the variable which I have in this for loop. So I will directly say, like, I want to print my name 10 times. So what I can say is I can use a range from 0 to 9, and then I can use a for loop and iterate over the values and print my name is Pratap. So in this case, I'll be printing my name 10 times. So this. So in this case, we were not using this variable I. So in this case, what I can do is I can just say underscore. In this case, if I want to ignore the value here, so I can use underscore and just print. Also, Python for loop has an else block. Okay. So print else. So how would this else work? So first of all, it will go into this iteration. So once this iteration completes, then it will go to the else block. This else block is an optional else block. So the else part is executed when the loop is exhausted. Today, let's learn about while loop in Python. So let's get started. So what's a while loop? So in Python, a while loop is used to run a block of code until a certain condition is met. So let's say we want to write my name is Pratap. Okay, let's write my name is Pratap here. Say print my name is Pratap. So if I want to write my name is Pratap one time, so this is okay. So let's write my name is Pratap. So we get one time, and let's say we want to write 5 times. So what we can do is we can copy this line and we can say 5 times, and then we can run this code. So we get this 5 times, right? But let's say we want to run this code 100 times. So it's not possible to copy and paste 100 times, right? Or you can say 1000 times or 10,000 times. So copy and pasting the same code, it's not feasible, and it's not what we should do in programming. In order to work with this, we have while loop. So what's a while loop? A while loop is used to run a block of code until a certain condition is met. How is the while loop? Let's say while we have some condition, and based on the condition, if the condition matches, then we'll do some statements. Okay, so this is how a while loops look like. So while is a keyword, has a condition. So based on the condition, it will go and run the statement. So it will run as long as the condition is met. Okay, so let's try one example. In order to work with while loop, we need to have some counter. Let's say if I say print your name 5 times, so in your mind you'll have to count something, right? So you'll say my name is Pratap, my name is Pratap, my name is Pratap, my name is Pratap, my name is Pratap. So you have to define this counter. So for that, we'll have some counter. Let's say counter equal to 0. Okay, or let's say 0. Okay, now let's check for the condition until my counter is less than or equal to 5. So we have a condition. So now let's have a statement. So we can say print, and let's say my name is Pratap. But now counter is 0. Okay, so we have to check the condition. So after we have this statement, we need to update the counter. So we can say counter equal to counter plus 1. So we say we are incrementing the counter by 1. Let's say, like I say, my name is Pratap. Now I increase the counter. My name is Pratap. My name is Pratap. My name is Pratap. My name is Pratap. So I'm increasing the counter. Okay. So if you run this code, you see we have this. My name is Pratap. We have here how much time? 1, 2, 3, 4, 5, 6 times. Why? Because we start with 0. So we check if our counter is less than or equal to 5. Let's also print the counter here. Say my name is Pratap, and let's say counter, and so that it will give us a more overview. So you see here we have a counter of 0 in the first iteration. So 0 is less than or equal to 5. Yes, it's less than 5. So it prints this statement. So here we increment the counter by 1. So now our counter, the value of counter is now 1. 1 is less than 5. Yes, it is. It will print the statement, and then it will increment the counter by 1. So now our counter value is 2. 2 is less than 5. Yes, it is. It will print this. So we increment by 1. 3 is less than 5. Yes, it is. And then we'll increment by 1. So counter is now 4. So 4 is less than 5. Yes, it is. It will print, and it will increment by 1. So we have 5. Is 5 less than or equal to 5? Yes, it is. So it will go and print, and it will increment by 1. So now counter value is 6. So is 6 less than or equal to 5? No, it's not. So it will end the loop. So if you see the flow chart, so we'll have some condition. So based on the condition, it will go to the body of the loop, and then it will go back to the test again. And if the condition is false this time, it will terminate the loop. Okay, so this is how a basic while loop looks like. We have this break keyword. So how can we use break keyword in the while loop? So let's comment this part of the code, and let's have the counter again. Okay, counter equal to 0, and you can say while counter is less than or equal to 5. So we should join this. Less than 5. So while counter is less than or equal to 5, and then we can check some condition here. If counter equal to, if the counter is 3, we will say break. Otherwise, we'll say print my name is Pratap, and I'll also print the counter. So here what I've done is I have a counter variable which has a default value of 0, and inside this while loop I'm checking the condition of this counter if it is less than or equal to 5. And inside the while loop I have this if statement. If the value of counter is 3, then I'm using break. So what is a break keyword? If there's a break keyword, it will break out of this loop. So it will go out of this loop. Okay, and if we run this code, we can see we have a infinite loop. Why? Because we never changed the value of counter here. So this is very dangerous. Let's increment the value of counter. It's a counter equal to counter plus 1. So let's run the code again. So you see here, so why did we get only this 3 output? We should have got 6 output like the previous example. That is because we have this counter check here. So currently the counter is 0. 0 is less than 5. Yes, it is. Is counter equal to 3? No, because counter is 0 right now. So it goes and print this. It increment the counter by 1. So now we have 1. 1 is less than or equal to 5. Yes, it is. Is counter 1 equal to 3? No, it is not. It goes to the statement. It prints and it increment. Now we have the counter is 2. Is 2 less than or equal to 5? Yes, it is. It's 2 equal to 3? No, it is not. It will go and print, and it will increment. Now we'll have the counter value is 3. Is 3 is less than or equal to 5? Yes, it is. It's 3 equal to 3? Yes, it is. So in that case, it goes and break. That means it will exit out of this loop. Okay, so this is how break keyword works. So let's run about this continue. So here in continue, like we can replace this break instead of continue. Now let's remove break and place continue, and let's run this code. So what does this continue does? So it will continue, like it will skip the next statement and it will continue the loop. So let's check how. So the problem here is the counter is 3 and it never goes to this counter equal to counter plus 1. Okay, so how can we fix this? Let's put this side, or maybe here. Let's replace this and let's run. So if you check this code, so how does this continue work? Let's take an example again. We have a counter equal to 0. So we increment the counter. Now counter is equal to 0 plus 1, which is 1. Counter 1 is equal to 3. No, it is not. It will go and print. It will go to here. Counter, the value of counter was 1. So 1 is less than 5. Yes, it is. So now we increment the counter by 1. So it is 2 now. 2 is equal to 3. No, it is not. It will go and print. It will go to the loop again. And then it will increment it 3 equal, like the value of counter will be 3 now. And if the value of counter is 3, yes it is, and then it will continue. So if you check here, when the value of counter is 3, it doesn't print anything because it doesn't go to this statement. It just skip the next part of the statement. If you can see here, like we have 1, 2, but we don't have 3 because we said that when the counter value is 3, we should skip the rest of the statement and continue with the loop. So this is how a while loop works. So we also have another use case of while loop. So let's copy this again. I would like to comment this. Let's paste it here. So we have else keyword in our while loop, and I can say else, and I can say print I am running from the else block. So if I run this, if you see now, if you check the output, we have this, so we are clear about this. But once the while loop is completed, the block of code will go to this else block and it will print this. But what we have to note here, another thing is, like if we use break here, like let's break after this and let's run this code, it will not go to the else block. We should remember that. If we are using break keyword inside the while loop, we should note that it will not go to this else block. But if we don't have any break statement in the while loop, in the body of the while loop, it will go to the else block. You can see from here, I am running from the else block. What is a while loop? A while loop is a block of code which is used to run a same code multiple times. Like in this case, I want to print my name is Pratap 100 times. So I will run the code 100 times. So while loop is used to run a block of code until a certain condition is met. So in this video, let's learn about list comprehension in Python. So what's a list comprehension? A list comprehension is nothing but, so list comprehension offers shorter syntax when we want to create a new list based on the value of an existing list. So let's say we have a list, let's say my list, and we have a number of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a list of number ranging from 1 to 10. We'll write a code to find the odd number here. Then we'll say for number in my list, and here what we'll say? We'll say if number %2 is equal to 0, then we'll say odd dot append. We'll add to the odd number. So what we'll add the number. Okay, so we'll do this way, and we can write print, and we'll print the odd number. Let's have some label odd numbers, and we'll say odd. Okay, so let's run this code and see the output. So we get odd number is, or it should be not equal to, because we are finding the odd number. Oh, my mistake, silly mistake. So it's okay. Let's run this code again, and we should see odd number is 1, 3, 5, 7, and 9. So here what we have done is we have created a new list of odd, and we are looping through the numbers to the list. And if the number is an odd number, then we are appending it to the new list. Okay. So, but we have a shorter way of writing this. Okay. So how can we write? Let's say we have odd shorter. What we can say, we can use list comprehension. So how is the list comprehension? We can say x, like let's write the same code. So we have here 4 numbers in my list. We can say number, let's write the same code, 4 number in my list. So this is the loop, this is the iteration, and we have an expression here. So we can say number. Okay, so this is the expression, this is the iteration. Like we have their iteration first, okay, and then we, from each iteration, we are getting this expression. So here this is equivalent to this, okay, and here we have this expression number. So we're extracting this number out here, okay, and then we can have another condition here. If number percent 2 not equal to 0. Okay, so if you see this code, we can see that we have an expression, we have this iteration, and then we have a condition. So we have all these things in the same line. Okay, so let's run the code again. Let's say odd numbers, and let's say here odd shorter, and let's say here shorter. And if we run this code again, we should see the same output, 13579. So we have this, like in this case we're having in one, like we created a list and then we loop through the numbers, and then based on the condition we append the number to the list. So here, when should we, like what is list iteration? So list iteration is basically when we want to have a new list based on the other list. So here we want to have a new list, odd shorter, which will have a list of odd numbers in it, correct? So in that case, we are having this list comprehension. Also, we can have a function. Let's say def is odd. So it's a function. It will take a number and it will return if the number is odd. So let me just copy number. So this is a condition. Here I can say num. So I have a function. It's odd. So based on the number input, it will return if the number is odd or even. Okay, so let me comment this print statement, and let's have a new comprehension here. Let's say let's directly use print list comprehension using function. So we'll be using the function in condition. Okay, I think we can use a variable here. Let's say a equal to, so what we can say, in order to use a list comprehension, we should have this square bracket. So here, what I want to do is, I will have a number. I will loop through the number num for num in my list. Okay, so we have this number now. So if I just do this one, it's like having the same copy of the list. So if I run this code, you will see I still have the list which was equivalent to my list. Okay, so now I can have some condition. I can say if is odd, and I can pass the num here, and let's run this code again. So you see we are getting the number if it is odd. So we are only adding this number in the list if this condition matches, correct? Also, we can have the same, let's say this time, let's say b, we can use a lambda function here. So how can we use the lambda function here? We can say if lambda, what does the lambda takes? It will take a x %2 not equal to 0. So this is our lambda. So I need to wrap this lambda inside a round bracket, and then I need to call this lambda. Okay, so let's run this code again. Sorry, so I need to pass this number here. So that's a mistake I've done. And let's say this. We can use this list comprehension in multiple ways, right? We can use it without a condition. We can use it with a condition. We can use it we can pass a function there. We can use a lambda. So this list comprehension is very vital in Python programming. So always remember, list comprehension offer a shorter syntax when you want to create a new list based on the values of the existing list. We'll be using this list comprehension based on the iterator, which is list in this case. So here we have learned how to loop through this number using our for loop, and also we have learned how to use a shorter like list comprehension. So we learned by passing a function. We also learned by using this lambda. Welcome back. So today we'll learn about Python dictionaries. So let's get started. So in Python, a dictionary is a collection that allows us to store data in key value. Let's say, for example, we can say my dict, use this dict keyword dict to create a dictionary. So I can say, so it should be in key value. So I can say name, and I can say my name is as Pratap, right? So you can see in Python dictionary, we define dictionary by using this curly bracket, and inside the curly bracket we have some key. So this part is called key and this part is called value. So this is the way we can create a dictionary. Let's add more value. I can add age. So my age would be something like 28, and let's say address. So this should be Nepal, and so on. Okay, so this way we can create a dictionary. Let's print the dictionary. Print my dictionary, and let's run this code. And you can see we have printed this dictionary like name Pratap, age 28, address Nepal. This is a valid dictionary. So now I can create a dictionary by using one. So I can say one is ONE. So let's run this code. So this is still a valid dictionary. So I can also do by using tuple. Let's say 1, 2, and I can say this is tuple. This is tuple. Okay. So if I run this, so this is still valid, but I can't have an immutable such as list. I can't say 1, 2 as a dictionary and say this is list. So if I run this, so you can see that we get unhashable type list. So we cannot have a list as a key because lists are not immutable. So we can change the list, but a tuple is immutable. So that's why we're able to have we are able to have string as a valid key, integer as a valid key, a tuple as a valid key, but not list as a valid key because lists are mutable. And also we can create a dictionary by using Python dict function. So let's say my dict2. So I can say dict, and here I can give key value. So I can say name up, and then I can say age should be 25, and if I can also print my dict2 print my underscore dict2, and let's run this code. Let me remove this key because this is invalid, so it doesn't make sense to keep it. So let's run this code, and you see we have a dictionary. So we can create a dictionary by simply using this curly bracket and defining a key value, and also we can create a dictionary by using the dict function, which is provided by Python. Okay, and we can also find the length of this dictionary. You can say length of my okay, so we can run this and you can get the length. So the length of this dictionary is 5. So since we have 5 keys here, name, age, address, 1 and 1, 2, which is tuple. So these are dictionary. Now if I want to print my name, I want to print Pratap. So how can I access Pratap here? That's very simple. If you want to access the item of the dictionary, you can use, let's say, my dict, and I can use by using this square bracket and then by adding this key name. So here I want the name. So this way I can access the item of the dictionary. So let's print this. So in this way, in this case, I should get Pratap. Okay. So if I want to access age, then I'll simply say age, and if I run this, I'll get 28. Okay. I also can use .get method in dictionary. I can say my dict.get, and I can give here the name of the key. So in this case, name. So let me comment this. Also, let me comment this. Let's run this code, and I get here Pratap, and I can say here level. So if I run this code, what should it happen? Because we don't have the level key in this dictionary, it should throw some exception. Okay, so it doesn't throw any exception, but it gives me none because there is no value. But in case of that, I can provide a default value. If it is none, then I can say test. You see, when we didn't have any default, like this is a default value. If we don't have this key present in this dictionary, then by default it will give the value of test. So these are the difference. If I run this code again, so here I'm getting test as a default value. In case there is no default value, then I'm getting none. We can also change the item of the dictionary by simply, let's say I can add my dict, like I can say directly, since I don't have level there, let me add level. So my dict dot level equal to 5. I'll say 5 in string. So now let me remove this and let me run again. So let me just print the dictionary. If you see, so I'll get here level. So this way I can update the dictionary. So here in this case, my dictionary contains only all these things, but now the dictionary, in that dictionary I'm adding this level, and I can also add a item to the dictionary by using update method. My dict dot update, so I can use update method, and here what I can say, I can use, so let's say there is no gender. Okay, so in the gender case I will give male. So now if I print this, I should get level and gender as well in the output. So you see, we have this level and we have this gender. We can also update the value of this dictionary item. To do that, we can simply say here, let's say address. I want to change my address to Switzerland or Paris or France. Okay, so here if I say, let me say Pokhara. So now you see my address is updated to Pokhara. So I can use the key and update it. Okay, I can also add item to the dictionary. So that way I can also add an item to the dictionary. And also we can also delete an item from the dictionary. So it's very simple. We can say delete. So to delete any item from the dictionary, we can use this delete keyword. Then I can say my dictionary dot, what do I want to delete? I want to delete this one, my dictionary, and let's pass 1. Let's run. It doesn't allow me to pass the string, so I can simply pass this. So here you see, we don't have that 1 anymore. If we want to remove all items from the dictionaries, then we have a dictionary method like myDict dot clear. If you use this clear, now my dictionary should be empty. So let's run this code, and you see we have an empty dictionary. So for now, let's not clear this. So this is how we can clear a dictionary. Also can loop to a dictionary by using the for loop, which we learned earlier. So let's say for item in my dictionary, let's print the item. So let's run this code, and you see we get only the key part. Okay, so we have already learned how to access a value. So we can say print my dictionary item. So let's pass this, and it will print all the item of the dictionary. So we can also get the key value. You can say key comma value, and you can say in my dictionary dot items. So when we use these items, it will give me key value, and then we can print the key value here. So let's say print key comma value. So if we run this code, we can see we have key, which is name, and the value is Pratap. Key is age, and the value is 28. Key is address, and the value is Pokhara. Key is 1, and the value is ONE, and the key is the tuple 1 2, and this is a tuple, and so on. So this way we can also loop through the dictionary. So welcome back. So in today's session, we'll learn about destructuring in Python. So let's get started. So first of all, let's learn about destructuring. What is destructuring? Destructuring is nothing but extracting the variable or extracting some values from a iterable into a variable. So for example, let's say we have a tuple. Let's say my tuple, and it has 2 items in it. Let's say 1 and 2. So let's print this tuple. Let's run this code. So we get 1 2. Okay, So in this case, how can we use destructuring here? We can use destructuring by saying, like, let's say a comma b, and let's print a, and let's print b, and let's run this code. So you see, we get the value of a is 1, the value of b is 2. That means we have extracted this item and assigned this to a variable called a. We have extracted this item and assigned it to a variable b. So we can do the same in a list. So let's have a list. So the list would be same. It will have 2 elements. Okay. And let's say D, and let's say CD. Okay. So in the same case, let's print C and D, and let's run this code again. So you see, so we can use destructuring in either list, in either dictionary, or in any iterable. So this is also called unpacking. So this syntax is also called an unpacking syntax. So now what we have to note here is, let's say we have 3 elements here in this list. Let's say we have 3. So let me just remove, or let me just comment others. Comment this, and let me comment this, and let's run this code. So in this case, we'll get an error because there were 3 items in this list, but we only destructure or extracted only 2 elements. So in that case, it says it expected 2, but it's getting 3. So here what we have to do, we have to do E, and in this case it will run now. Okay, so I forgot to print E, so we can do it simply like this. E, let's run again, and we're getting this. So in that case, like, there may be a case where we may encounter, we don't know the length of the list. Let's say there are 4, 5, 6, 7, and the list can go on big size of this list, right? So in that case, let's say we are only interested in the first 2 elements, but we are not interested in the rest of the element. So in that case, what we can say, we can use this star. Star means like getting all the rest of the element and adding into this variable. We didn't do anything fancy here. We just extracted the first item and assigned it to the variable C. We extracted the second item, and then we assigned this to the variable D, and then we extracted the rest of the element and assigned it to the variable E. So if we run this code, it will be more easier to understand. You can see we get 1, which is C, we get 2, which is D, and then we get a list of numbers, which is E. We get the list of rest of the numbers. So we can also do one thing here. Let's say we are interested only in the first and the last element, but not in the element which are in between of them. So in that case, we can say star D, and we can remove the star here. And if I print now, we should get C, which is 1, and we should get E, which is 7, and we should get 2, 3, 4, 5, 6 in this variable D. So let's run this code. So you see, we get 1 in the variable C. We get the list 2, 3, 4, 5, 6 in the second item in the variable D, and then we get 7 in the variable E. So we can use this same thing in the tuple, or any type of iterables. So what we should note is, like, if we know the length of the list, then we can directly give, like, let's say the length of this tuple is 2, so we can use 2 variables. But if we don't know the length of this tuple, we can use this star, which is called extract everything else into that variable. So if you want to ignore the variable, let's say I want to ignore the list, the item in the middle, so in that case I can use underscore and ignore it. So it's simply like this. So I can just print C and D. So in Python, we use underscore to ignore the variable or the value. So far, what we have learned is, we have learned how to unpack the iterables like tuples and list. We have also learned how to unpack 2 variables. We have learned how to unpack multiple variables, and we also learned we will get an exception if the number of variables here and the items in the list or tuple would not be same. We'll get an exception. We also learned how to ignore the items in between, and we also learned how to get the first element and the last element. So welcome back. So in today's session, we'll learn about functions in Python. So let's get started. So what is function? So a function, like in programming, a function is a reusable block of code that executes a certain functionality when it is called. So in Python, there can be 2 types of functions. It can be a standard library function, or it can be a user-defined function. If you remember in our previous example, let's say we use dict here, right? So this is also a type of function. If you remember update here, so this is also a type of function. So basically, what is a function? A function is a block of code that will do a specific task at a time. So how do we define function in Python? So to define the function in Python, we need to write this keyword def and the name of the function. and this will be the body. So how do we define a function in Python? So in order to define a function in Python, we have to use this keyword def. It means define, and then we are giving the name of the function. Here we are saying function name, and it should be inside this parenthesis. So when we have this parenthesis, so it means that this is a function, and we have this colon. After that, we have this part called body. So here in the body, let's say print learn with Pratap. So I have defined a function, and what does this function does? This function just simply print learn with Pratap. But if I run this code, nothing is happening, right? Because we just defined a function. So now, as we have defined the function, now we have to call this function to make this function work. So how can we execute or call this function? So we just simply run the function like this. In line number 13, what I'm saying is I'm just calling this function. So how can we call the function? Write the function name, the name of the function, which is function name, and you need to call by a pair of parentheses. So now if I run this code, so you see, we have learned with Pratap in the console now. So how exactly this works? As we say, code in Python works serially, like sequentially. So it goes to line number 8, and in line number 9, it's a function. So it's defined this, it stores something, like it stored this function somewhere in the memory, and then it goes on, and in line number 13, it shows that, oh, the function was being called. Okay, let me call the function. So now the block of code that was written inside this function, it will run. Let's take another example. Let's say we have a function called sum, which would basically add two numbers, and we'll say a equal to 10, and we'll say b equal to 11. And here what we do, print sum of two numbers is, then we can say a plus b. So if we run this code, still we just define the function. Okay, so what we say, we define a function called sum, and inside the function we say that a equal to 10, b equal to 11, and then we print sum of two number is a plus b. But when I run this code, nothing is happening, right? As I told you earlier, now we need to call the function. So if I say sum, if I save and run, you see sum of two number is 21. That means the functionality of this sum function is it will simply add two numbers. It will simply add a and b. This is a function. So this is how a Python function works. We have defined a function def greet, and then we have some code inside here, and we call this function from this line, from this tree. So what exactly happens is our code will go like this. It will go sequentially, and then it will go here. It will see greet. It will go inside this greet. It will run this code, and once the code is executed, it will go to the next line of this greet function. So as I've told you, there are two types of function in Python. One is a standard library function, and one is a user-defined function. So these functions which are defined by user, these are called user-defined function. And the function which we were using earlier, like update or dictionary, so this print is one of the function. So print is also a type of function. So what is the functionality of this print? The functionality of this print is it's just go and print this to the console. So as we told, a function is a reusable block of code that executes a certain functionality when it is called. So here you can see we have this print function defined somewhere. So what's the functionality of this print? So it just prints something to the console. So here we are reusing this function, right? We are using this print function inside this function name, and we are also using this print function inside this sum. A function is a reusable block of code that executes a certain functionality when it is called. So we'll learn more about functions. Function can take parameters, arguments, and all. Function can return something. So we'll learn more about this in the upcoming sections. So welcome back. So let's learn more about functions in Python. So let's get started again. So far, we have learned how to define a function, how to call a function. So now let's learn about argument in a function. So what's argument? So let's learn about argument. So an argument is a value that is accepted by a function. So let me comment all this code, and let's write another code. So let's define a function that will add two numbers. You can say def add numbers, and let's have this first, and also let's say here do something, and again let's just simply copy paste this. Okay, and let's say we'll have here num1 num2. So if you see the function, so we defined a function called add numbers. So we have here and we have here also. So earlier we have learned without an argument. So we said in order to define a function, we should have the def keyword, we should have this name, the name of the function, and we should have this pair of parentheses followed by this colon, right? But if you see here, I've written num1 and num2 inside these parentheses. So anything we define inside this parenthesis is an argument. That means this add number function, it accepts two values, which one is number 1, one is number 2. Okay, so let's remove this, and let's simply say sum it's equal to num1 plus num2, and then we'll say print sum is, should be print, we'll say sum is sum. So how can we call this function? We have defined a function, but we need to call it, right? So add numbers. Earlier when we had only this part, like we don't have num1 and num2 in the parentheses, we just say that we just call the function this, like this, right? We just call a function like we pass nothing in this pair of this parentheses. But now, since the function add number accept two arguments, two values, I need to pass two values here. So how can I pass that? Let's say I pass 19 and I pass 20. If you see carefully here, this 19, when I call this function add numbers, so I pass here 19 and I pass here 20, right? So we know that the add numbers accept two values, number 1 and number 2. So this 19 will go and sit in this variable number 1, and this like this 20 number, like number 20, will go and place in this num2. Let me confirm that. Let's say print, let's say num1 and let's say num2, and let's run this code. So you see, so to be precise, let me say by using this f string, we can say num1 equal to, we can say num1, and we can space like num2 is equal to num2. So if I run this code again, you can see num1 is 19, num2 is 20. So whatever I passed here, like I passed 19 here, it goes to num1. I passed 20 here, it goes to num2. So we can confirm this way. So let me uncomment, let me remove this, and let me uncomment this, and let me run this code. So you see, now sum is 39. That means this is a function add number. What does it does? It just simply takes two numbers as an input, and then it add both of the numbers and print the result to the console, right? So this is the functionality of this number. So far we have learned how to define a function, how to call a function, and we also learn about the different types of functions. And now we also learn about the arguments of a function. So a function can have any number of arguments. I can have num3, I can have num4. A function can have no arguments or any number of arguments. So now I can pass 21, I can pass 22. Like we'll learn more about the arguments, like we have default arguments. A function also can return some values. So we'll learn more about them in the upcoming session. So welcome back. So let's learn more about function. So as we have learned more about these functions, like it accepts these arguments, you can pass these parameters. So what's the difference between parameters and argument? So when I pass anything to the function, there is a parameter. So whatever the function accepts, that's an argument. So let's say here we have two numbers like num1 and num2. This add number accept two numbers. Okay. So here I can also pass as a named parameter or name argument. I can say num2 equal to 10, and I can say num1 equal to 19. So this is a named parameter or named argument. Yeah. So if I run this code, I still get 29. So that means here the value of num2 would be 10. Even though I'm passing this as the first argument, what I'm saying is num2, the value of num2 should be 10. So here num2 will be 10. So here I'm saying num1 will be 19. So let's print this. Let's print num1 and let's print num2. Okay. And let's not pass anything in this. So you see, we have this position argument cannot appear after keyword argument. So if we're having any named argument, we should have here first. So we should pass all the argument first, and then only after we pass all the other arguments, we can only pass the name arguments. So let's run this code again. You see, we have sum is 29. But what happens if I say num1 equal to 10? Let's run this. it says got multiple value for argument num1 because I'm passing this 19. So it says num1 should be 19. And I also said that num1 equal to 10. So it says num1 is 10. So in this case, it gets multiple arguments. So it's not correct. So we cannot mix it this way, right? So these are named arguments. Now let's say I just passed 19, and we can also have a default argument. Let's say the value of num2 should be 20 by default. If nothing is passed in this argument, like if I run this code, I pass simply 19. But you see, the value of num2 is 20 here because I didn't pass anything. When nothing is passed as an argument, this function will pick the default argument. Here I said the default value of num2 should be 20. But if I pass anything value other than 20 here, let's say in the argument, well, my num2 would be 29. I hope you understand here. If I pass any number, like if I say I have this default argument as 20, num2 is equal to 20, and I don't pass anything here. So in that case, the function will go and pick the default value. So these are all named argument and default arguments. So we'll learn more about this function in the upcoming sessions. So welcome back. Today, let's learn about a function which returns a value. So let's get started. So far, we had this add number function which accepts two numbers, num1 and num2. And based on the input, we were adding this result, right? We are getting sum equal to num1 plus num2. For now, let me remove all this, or let me just comment it, and let's write the new function again. I'll copy this and I'll comment. Paste. Let's uncomment. And let's remove this default value. Let's remove this print. Let's remove this print also. And let's pass here 20. Okay. So here we have a function add numbers which takes two inputs, num1 and num2, and it adds them. Like we get a sum equal to num1 and num2, right? So I want to return something from here. So when I call something, I want to get something. So in this case, when I call this function, I want the sum of the two numbers rather than printing in the console, right? So a Python function may or may not return a value, right? But here in this case, it doesn't return a value. Or for example, in this example, it didn't return anything, but it prints something to the console, right? But in this case, we want to return something. So in order to return something from this function, we should use this return keyword. So here I want to return sum. That means if I don't specify anything here, let's say I don't specify anything after this return, that means here if I say print my name is Pratap, so you can see it says code is unreachable. That means after this return keyword, I cannot write any code. So a function may or may not return a value, right? As I told you. So let's say here total equal to add numbers. So now if you see, I can assign this function to a variable, right? So let me print this total. And let me run this code. And you see we get none because it doesn't return anything. Let me remove this return also and let me run this code again. Still same, right? It doesn't return anything. But now if I say return sum, if I run this code, so you see now we get the sum of these two numbers. That means when I call this function add numbers, I pass two numbers, which is 19 and 20. And I call this function, it accepts two number, num1, num2. And here we are adding num1 and num2 equal to sum, and we're assigning it to some variable. And when we, in line number 32, we are returning the sum. That means a function may or may not return a value. Okay. If we want our function to return some value to a function call, we use the return statement, right? If we want the function to return something, then we use this return keyword followed by what it should return. Okay. So here, if you can see, we can also specify the return type here. Like we can specify the return type by saying int. So this specifies that this, when I call this add numbers, it should return a number. Okay. Here also I can say it should be int. It should be int. And now if I check my total, you will see we have the integer type. My total is integer type. So these are called data types, specifying data types in Python. So we'll learn more about them in the upcoming sections. Okay. We have these add numbers. Also, let's define another function. Let's say def find square. Let's say num. and then we will return the result. Okay. So how can we find the square of the number? So to find the square of a number, we can say let's return num into num. So this is simple, right? Now I have a list, let's say my list or my numbers 1, 2, 3, 4. Okay. If you remember the definition of function, we said that a function is a reusable block of code, right? So here, so what is this? This is a function. That means I can use this function anywhere. Like if I want to find the square of 1, if I want to find the square of 2, so I can use anywhere, anytime, right? I want to find the square root of all these numbers. So how can I do that? So let's combine all the knowledge we have gained so far about list comprehension. Square of numbers would be equal to list comprehension. Now first of all, let's write for num in my numbers. So we'd say here, we'll get the num here. So what we can say here, we can say find square for num. So this is a list comprehension. As you've learned, we have the square bracket. So we're looping through this my numbers, and for each of the numbers, we are finding the square, and this find square function returns the square of the number. So if I print this, let's print square of numbers. So if I print now, so you see, we find the square of each of the numbers in this list by using list comprehension, by using this function, a function that returns some value. You see, we have 1, the square of 1 is 1, 2 is 4, the square of 3 is 9, the square of 4 is 16. So this way we can use the function. We are using the function, right? For this 1, we are using this function. For this 2, we are using the function. For this 3, we are using the function. So this way in programming, a function is a reusable block of code that executes a certain functionality when it is called. I hope I'm able to help you out with this. So let's learn about the benefit of a function. Benefits. So the first one is code reusable. And number 2, according to me, is code readability, right? So from here, we can see that the first point, the first benefit is code reusable. So we can reuse this code multiple times, right? And the second benefit is code readability. You can see here, when I read this function, we exactly know what it does, right? When we find square and we say num into num, so we know what this function does. So this function takes a number and returns us a square of the number. And if we check this add numbers, so it's very clear that it accepts 2 numbers and then it returns the sum of those 2 numbers, right? So these are the benefits of a function. So far, we have learned what function is, we have learned the type of function, we have learned how to define a function, we have also learned how to call the function. Also, we learned how a function can do a specific thing, like in this case, it was adding 2 numbers. We also learned how a function can return a value, and we also learned the benefits of this function, code reusable and code readability. In Python, Lambda or anonymous function is a special type of function without the function name. We can say lambda, we have to use this keyword, then we can say this colon, and you can say print. Print, let's say, hello. This is a lambda. So as you can see, it is a function, but it doesn't have any name. So if you don't know about function, please go and revisit the function section in this tutorial. So here we have created a function, a lambda function that prints hello. If you go and check this, so while defining a function, we use this def keyword followed by the name of the function. But in lambda, we just define a function by using just simply the lambda keyword. So let's see how the syntax of lambda. So it should be like this, lambda, and it will be argument, and then it will be an expression. So we will write lambda, and then here we can write an argument. So let's say we have an argument of name here, then we will say hello name. So you see, so this part is called an expression, this is an argument, and this is a lambda. This is how we declare a lambda function. Okay, so now if we want to run this lambda function, so we can do in multiple ways. Either I can wrap everything, let's say I can wrap everything and I can run this function, and I can say Pratap And let me run this code. So you see, we got here hello Pratap. So let's say this lambda doesn't accept any argument. In that case, let me remove the argument. So I can run this function this way also. I can also assign this lambda function to a variable. Let's say greet. So now my greet is a function. So since we defined a function, now we can call this function. Let's say greet, and let's run this. So here, let's say hello, or let's say hello greet. So here you can see that there are multiple ways of running this lambda function. Either you can run it in the same line, or either we can assign it to a variable and call the variable. Also, let's take an example for a lambda function that takes an argument. So here, let's say this lambda function takes an argument of name, and here let me remove this greet, and I'll accept this name. And then if I want to pass the argument here, I can pass from here. I can say Pratap, and if I run this code, you will see hello Pratap. This way we can pass an argument. Here, whatever I'm passing in this argument, it is going and assigned to this name variable. And when I print this, like in this expression, when I print hello name, then it gets hello Pratap. So this is how I call the lambda function. So we'll learn more about these functions like lambda functions, or a normal function. We'll use them more frequently in the upcoming projects and all. So I think for now, this is a simple overview of lambda function. We'll learn about it in the upcoming section. So in today's session, let's learn about dictionary comprehension. So what is a dictionary comprehension? Dictionary comprehension is an elegant and concise way to create dictionaries. So let's say we have a code like this. Let's say we have square, we'll say dict is equal to dictionary object, like, and let's say for num in range 1 to 11, I can say square dict of num is equal to num into num. Okay, and now let's print square dict. So if I run this code, so you see we have 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, and so on. So I can do the same thing by using dictionary comprehension. So let's do the same. Let's say square dict, let's say com equal to, okay. So in list comprehension, we had square bracket, but in dictionary comprehension, we'll use this curly bracket. So whatever we write here, let's say for, let's say num in range 1 to 11. So these are loop. So this part, this is our loop. Now I want to define this square root and all, right? Square dictionary and all. Since I have this num, what I could say is num, I can say colon num star num. So now if I print square dict com, let's run this code. So you see we have the same result. So dictionary comprehension is just an elegant way to define or to create dictionaries. So in both this code, we have created a dictionary with the number, like the number square, we have this key and this is the value. So for every number, like we have this key and this value, right? Using the dictionary comprehension, we're able to do it in the single line. So let's learn about the pattern of this dictionary comprehension. So let me just copy this part and let me add in the command. So this will be iterable. This will be var, this will be var, this will be var, and this will be var. If you see, we said for vars in iterable, so we all know how our for loop works. What I could do is I could set this variable as a key and this will be the value. So for simplicity, what I could do is let me just copy this part and let me print. I can just do it directly here. Let me print. So instead of num into num, I can say Pratap. Let me run this code. You see, for every key, I have this num. This is the key. For the first iteration, it will be 1 and the key will be 1. So the value is Pratap. So you can see in every item, in every key, I have this value Pratap. So let's assume we have a dictionary. Let's say old price. Let's say milk. It cost us 1.02. Okay. And we have another variable, let's say veg, it cost us 2.5, and we have spinach, it cost us 3. These are the old price. Let's say the price is in dollar. Price is in dollar. I want to convert this price to NPR, in Nepali rupee, right? And dollar to NPR is equal to 131. So $1 equal to 131 Nepalese rupees, right? So now what I could say is new price is equal to, I can use the dictionary comprehension. So I think when you write this dictionary comprehension, it's better to go backward. So what I could say here is, let's say for, let's grab the key and value from this old dictionary. Let's say for item value in old price dot items. So this way we'll get, if we say old price dot items, then we'll get the key value of this dictionary, right? So now what I could say is, I can say item is equal to value into dollar to NPR. So here if you see, so this part, it's a simple for loop. We are iterating through the dictionary by grabbing this key value, and for every item we are assigning a new price, which is the current value, into the NPR rupee, right? So now I can print new price. So let me comment all this. Let me comment. Now we should have only one print. Let's run this code. So you see the new price of this milk is this one. We have this veg, we have this spinach, right? So this is how we can use dictionaries. Let's learn about the advantages of using dictionary comprehension. So the first advantage is it shortens our code, right? Shortens our code. And the other is, so it makes our code a bit Pythonic, right? Pythonic. So these are the benefits or the advantages. So today we'll learn about how we can unpack an argument or a keyword argument. So let's get started. So in Python, we have star args and star kwargs. Star args, we use this to unpack an argument, and star kwargs, we use this to unpack a keyword argument. So let's say we have a function. Let's say we can define a function. Let's say adder. We'll say x, y, right? And what it would do, it will say print, we'll say sum, and we'll say x plus y plus z. And now if I call this adder function, let me call this adder function, and let me pass 10, 11, and 12. So if I run this code, you see we get sum is 33. So if you don't know about functions, please revisit the previous sections about functions so that you'll be able to understand what arguments are, what keyword arguments are, okay? Here we have a function called adder. It accepts 3 arguments, let's say x, y, z, and we're calling this function adder by passing 3 arguments. But if you see the name of this function, it says adder, right? Someone who's calling this function, he or she might not know like how many arguments it accepts, okay? So let's say if I pass here 3 arguments, what happens in that case? So let me run this code again. So in that case, we get this type error. So error takes 3 positional argument, but 4 were given. So how can we make sure that even if we pass many arguments or when the number of arguments is not known, how can we handle all those? In Python, we can pass a variable number of arguments to a function using a special symbol. Those are star args and star kwargs. So first, let's learn about Python star args. Okay. So as you can see in this function, we don't know the number of arguments we are receiving, right? So in order to fix that, what can I do is, let's say instead of this, I can say star and I can say num. So before going ahead, let's just go and print num. And let's run this code. So you see, whatever argument which we gave here, so it goes and we receive as an argument here. So the type of argument which we received is a tuple now. So if you don't believe me, let's try type and let's say type of num, and let's run this code. And you see, it's like it's of tuple type, right? So that means if I use this star, so this is called unpacking arguments or unpacking non-keyword arguments, because we can have multiple arguments, right? So let's say I have one keyword argument here. Let's say name equal to Pratap, from this 10 to 13, it's a non-keyword argument, but this is a keyword argument, right? So if I go and run this, you'll see it says type error got an unexpected keyword argument name, right? So now if I want to handle that, I can say star star ABC, for example. So let me print that again so that you'll get the gist of that. So you see, as we all know, we can call a function by passing non-keyword argument or a keyword argument, right? So these are non-keyword argument because we don't have any keyword, but here we have a keyword argument, which is name equal to Pratap. So this name is a keyword, right? So whenever we pass a non-keyword argument, so those things goes into this star nums, and the type of that star num is a tuple. But on the other hand, if we have a keyword argument, so in that case, when we receive an argument here, when we receive this value, so the type of this value is a dictionary. Don't believe me, right? Let's add another thing, age equal to 25. So now let's print the input which we got, and let's run this code again. And you see the non-keyword argument, we receive this as a tuple. So you can see here, so this is a tuple, and the keyword argument which we passed in this function, we received as a dictionary, right? Now let's go to the point again. Let's remove all this. First, let's learn how the star num works. Okay, so let me remove all this code. Now, since I don't know the number of arguments that a caller would send, so I say star num, or more generic way in Python is args. These are arguments, right? Non-keyword arguments. So let's say here, let's try to find the sum equal to 0, and let's say for num in args, sum equal to sum plus num, and let's print the sum. Okay, so let's run this code. So we get 46. So now I can call this function with any number of arguments I want. Like let's say I want to call with just with single argument. I want to call it with multiple arguments. So let me run this code. So you see, so now this way my function, this error function is more generic now, right? So it can accept any number of arguments. It can accept a single argument. It can accept multiple arguments. Now my error function is more generic, right? So now as we have learned about this star args, you should always remember what is star args. It's unpacking arguments. It is only for those arguments which doesn't have keyword, right? So now let's learn about this star kwargs, unpacking a keyword argument. So as I have told you earlier, like even though I'm passing, like if I say star kwargs, so even though I'm passing multiple arguments here, nothing will go into this kwargs like keyword arguments, right? So for now, let's just leave it like this. Let me define another function. Let's say define introduction. Okay. And for now, I'll not do anything. So let me call this introduction function. Now, when I want to call this introduction function, I would like to say name equal to Pratap, and then I'll say age equal to 25, and I'll say address equal to Nepal. Okay, and also let me pass one more argument here. Let's say let me pass 10 just to demonstrate the difference between the arguments and the keyword arguments. So here I divide the function introduction. So here let me accept args, and let me accept kwargs, and let me print those both. Let me print args, and let me print kwargs. Okay, so let me run this code. So you see, for now let me just comment this part because the more thing we got in the console is a bit more confusing. So here if you can see args, like I passed 10 here in the argument as a non-keyword argument, so that goes into this tuple. Okay, and whatever named argument or named like keyword argument which I'm passing to the function, so that's all those things are getting to this kwargs or a keyword arguments, right? I hope you get a gist of the star args and star kwargs. So let me remove this, and let's write a function to greet this one, right? Let's say, as I've already demonstrated in earlier, the data type of our kwargs is dictionary. So let me just add here print data type of star args is, let's say, type args. So let me copy this and let me just edit here also. Data type of star kwargs is kwargs. correct? So now let's use our for loop and let's loop through the dictionary, because we know how to loop through a dictionary. For, we'll say key value in, and let's say kwargs dot items. Since our kwargs is a dictionary, we can say items, right? Let's say print this. So it's very simple. Let's say key is, let's say value, right? So now let's run this code and let's see what we get in the output. Oh, since I removed the argument part, so I think I should remove this part because it gives me an error because it takes 0% argument, but I was giving 1. Okay, so let me run this code. So now you see the data type of this star kwargs is class of type dictionary type. So it is of type dictionary. So name is Pratap, age is 25, address is Nepal. Very simple, right? So now I can reuse this function, more generic term. So now I can say Madhav, and he's of age 30, and he's from, let's say, somewhere from Bangladesh. And let's run this code. So you see, name is Madhav, age is 30, address is Bangladesh. Okay, so let me run this code again just to see the type of the input which you're getting. So you see here, so the type of star args is of type tuple. So I hope I'm able to make you understand. So what exactly star args or star kwargs is, how we can unpack an argument or how we can unpack a keyword argument. So this way we can make, like this way we have made our function more generic. So we can pass any number of arguments. By using this also we have made our function more generic. We can pass any number of arguments. Okay. So now let's learn about what we should remember while using these arguments or keywords. So star args and star keywords are special keyword which allows function to take variable length argument, right? So this way we have made our function more generic, and star args passes variable number of non-keyword arguments and on which operation of the tuple can be performed, right? We all know that now. We all know that when we pass a non-keyword argument, so this changes to a type of tuple. So when we pass as keyword argument, then it goes and changes into a type of dictionary. And star args and star keywords makes a function flexible. So now we can pass any number of arguments, any number of keyword arguments, right? So far we have learned about the star args, we have learned about the star keywords. So star args is called unpacking an argument, and star keywords is called an unpacking keyword argument. So we have learned how to use the star args. So how we unpack the argument, non-keyword argument. So we learned also the type of the arg. We have learned how to make the function more generic. We also learned how we can use these keywords. We made this function more generic, and we all know that the type of keywords is a type of dictionary. And we also learn about what we should remember for this star keywords and star args, right? Welcome back. In today's session, we'll learn about object-oriented programming in Python. So let's get started. What is object-oriented programming? Object-oriented programming is we should have a class, and based on the class, we'll be creating an object. So Python is a versatile programming language which supports multiple programming styles. So it supports functional programming as well as it supports class-based or object-oriented programming. Okay, class is an object. So an object can have any entity that has attribute and behaviors. Like for example, let's say we have a bird. Okay, for specific, let's say a parrot. So let's say we have a parrot and it has 2 attributes. Let's say, so it has the attributes like the name, it can have age, it can have color, and it can have some behavior, right? So behavior, it's like it can fly, it can sing, etc., right? So since this is an object, so we say this parrot is an object, we can say that a class is a blueprint. How can we say that? Because like let's say an object is simply a collection of data. A class is a blueprint of that object. So let's take an example. How do we define a class? Okay, we need to learn how we should define a class. So defining a class is very easy in Python. We can say class, and it will be class name, and we'll have the definition. Class definition. For now, let me just comment this part. So this is how we can create a class. Correct? So let's say we want to create a class called bike, and this bike will have, like we said, that it has few attributes. So attributes can be like name. So for now, let's add it to empty, and we have gear, and which is also equal to 0. So these are attributes. If you can see, we have a bike, and then this bike has certain attributes, right? Bike is the name of the class, and name and gear is the attributes or variable inside this class. And for now, the name is empty and the gear is 0, right? The variables inside a class are called attributes. I told you here attributes. So what are attributes? Any variable that are inside this class are called attribute. So we just say that classes are blueprint. So now what we can say is whenever I create an object of this class, so that object would have these two properties or these attributes. Okay. So let's create an object of this class. So I can say pulsar is equal to bike. So this way we can create an object of a class. So this is class, this is the name of this class bike, and this pulsar is the object of this bike. So I can have this way, I can have multiple objects. I can have here Yamaha, I can have here TVS, I can have here unicorn. So these are the different objects of this bike. So each bike will have this attribute name and gear. So now we can use this object to access the class attributes. So how can we say that? Let's start with pulsar. Let's say pulsar dot, so we have their name, right? Name. What I could say, so which type of bike do we have in pulsar? Let's say we have pulsar 180, right? So this is a name. And if I want to access this attribute, let's print pulsar. Let's try to run this code. So we see some gibberish. But now if I say pulsar dot name, and if I run this code, you'll see we have this name, pulsar 180. The same way I can assign pulsar dot gear. So currently it is in 4th gear. So if I run this code again, and let me add gear here. And if I run this code again, you will see I have pulsar 180 and it is currently in 4th gear. So far, we have learned how to assign an attribute. We learned about the attributes. Now we can have a behavior also, right? Let's take another example. So let me comment this part, or let me just comment this print part, and let's create a new class. Let's say we have a class called room, and a room can have two attributes, length, which is equal to 0, and we can have breadth, which is also equal to 0, right? And we have a method or a behavior. Let's say def calculate area self. We'll say here print, let's say f area of room is equal to, it's very simple, let's say self dot length to self dot breadth. So if you see, we have these two classes here. I had class bike. So this class bike has just two attributes, right? Name and gear, but it doesn't have any methods. If we have any Python function inside a class, and we call that a method. Okay. So now we have this class room. So these are the attributes of this room class, and this is the method of this room class. Okay. So what's the difference between function and a method? So function, it's normal when we use some keyword called def and with the name of the function. So there's a function, but any function that resides inside a class, it is called a methods. Okay. So now let's start to create an object of this class. Let's say dining room equal to, we can say room, and you can say dining room dot length equal to, let's say 100, and you can say dining room dot breadth equal to, let's say 80. So now if I want to find the area of this room, so I can simply say dining room dot calculate area. So if I run this code, we'll see area of room is equal to 8000. Why is that? Because length into breadth is 8000, right? So now let's understand what exactly we have in this method. So first of all, we define a method. The difference between function and method is that in this method, we'll have this self. So what is this self? So let's print this self. Let's run this code again. So when I print self, you see we have this object. It means that we have this object at certain location. So when we say self, so it's currently corresponding to this particular object, which is dining room. Okay. So when we say self here, so the self means we are pointing it to this dining room. So that's why I'm able to say self dot length. When I say self dot length, let me say self dot length, and let me also print the breadth, self dot breadth, and then run this code. And you see we have this 110. I assign this length to 100, and then I assign this breadth to 80 right here. So when I say self dot length, so I'm able to access the attribute of this object, correct? So that means what is this self? This self means this particular object. So if you can see here, we have this calculate, it should have this area. It's okay. That's typo. So you can see we are assigning the value of this length and breadth using this, right? Like this. So we can also assign a variable using a constructor. Okay. So for example, let's say we have a class called human, and let's say it has a name equal to some empty string, and let's say it has age of equal to some empty string for now, correct? So what's a constructor? So if you can see here, let me just define the constructor. So if you can see a constructor here, for now, let me just comment, let me say pass, so that if I don't get this error. If you see, we have this underscore underscore init underscore underscore. So these type of methods are called dunder method. What are they called? They are called dunder, D-U-N-D-R, dunder method. Okay. So here, if you can see here, this underscore underscore init method, this is a constructor. So when is this function called? This function will be called each time a new object of this class is created. So let's say we have tab. Okay. We'd say human. So let me print here, I'm cold. So let me run this code. So for now, let me comment this part and let me run this code. So you can see I'm cold. That means whenever we create an object, whenever a new object is created, then this constructor method is being called. Okay. So this constructor method, like if we define or we don't define, it will be called by itself. Okay. I want to initialize the name and age, right? So this should be, let's say 0 for now. It should be number. So here, this constructor can accept 2 arguments. So I can say here name and I can say here age, correct? So now what I can say is self.name is equal to name, and I can say self.age equal to age. So now when I create an object of this class, I need to pass the name and this age. For this instance, let's say Pratap, and I can say 20. Okay. So let's print here. So let's print name and age, and let's run this code again. So you see, so whenever we instantiate a class, so whatever we're passing here, this is going and we're getting in this value, and then we are setting these values inside these variables. So when I say self.name, what I mean is I'm meaning to this attribute of this particular object. Okay. So here, when I say self.name, it basically refers to the attribute of this Pratap, correct? So if we use a constructor to initialize values inside a class, we need to pass the corresponding value during the object creation of the class, which we are doing here. This is the basic concept of class. So we have learned about constructor, we have learned about how we can define a class, we have learned about the attributes, we have learned different ways of creating an object, like we can create an object this way by passing an argument like this, or we can do by assigning the attributes like this. These are multiple ways of creating an object based on the class. So what we can say, so a class is a blueprint and objects are created based on that blueprint. Okay. So here we have created a class which has only attributes, and then we create an object based on that, and we assign the attribute by using object dot notation. So pulsar is an object dot name. So this is the attribute. We assign the value, and then we created a class which has 2 attributes here, length and breadth, and also we have a method here. So whenever we define a method inside this class, we should always have this self as the first parameter, because we should always know that this is the current instance, which is this dining room. So when I say self, so it means that at that moment it is the dining room. Okay. So in here I'm able to access the attribute of that object. When I say self.length, so what I mean is it is dining room.length. So when I say self.breadth, what I mean is dining room.breadth. Okay. So we also learn about constructor. A constructor is being called whenever we instantiate a class. So whenever we create a new object of that class, this constructor method is being called. Okay. So we'll learn more about classes and object in upcoming sections. So please follow along and code along with me. Welcome back. So in today's session, we'll learn about magic method underscore underscore stir or underscore underscore wrapper method, or also known as dunder stir or dunder wrapper method. So let's get started. So in Python, when we say dunder method, we actually mean the class methods which starts with underscore underscore. So we have init, we have stir, and we have wrapper method. So these methods are defined in a Python's data model. So the stir and the wrapper methods can be helpful while debugging or while printing the useful information about the class or about the object. Okay. So first, let's understand the difference between stir and wrapper by using the built-in class. So we can use built-in class. Let's say, let's import date time. Okay. Now let's create a new instance of date. Let's say my date. Let's say datetime dot now. Like this, we have created a new date. So now let's print, let's say underscore underscore str. So we can say my date dot underscore underscore str. We have this dunder method in every object. So we create a new object of this date time. So we say my date. So for every object that is created, we'll have this dunder method. So let's copy paste. Let's say star, and then it will be string, and it will be string of my date. You can remove this. Okay, so this is for the string. Let's have the same for the wrapper method. So we can simply copy paste, and let's say, so instead of this str, we can say repr, and here I can say repr, and instead of str I can say repr, and instead of this one I can say repr. So this way we have this object. So we are currently using the built-in class method. Okay? So these are all the built-in class. So I've created a new instance of this class. We have this my date. If I run this code, let's run this code. So you see for this star, we have this string. This is basically all this gibberish. We have this star. This we have used earlier to typecast a integer into a string. So when I typecast this, we are getting the same result, right? If you compare these two, we still have the same result. And if you check this, we have the same result, right? So this was for the built-in class. So now let's comment all this and let's create our own class. Let's say we have a class of shape, class shape. So this class, it will have a, let's define the constructor in it. This will get the shape. For example, it will have length, or let's say like instead of shape, let's say rectangle. So it will have length and it will have breadth, right? Or maybe for simplicity, we can say, let's say room, as we have used in the previous example. And here what we can say is, we can say self dot length equal to length, and you can say self dot breadth equal to breadth. Okay, so having length equal to 0 and breadth equal to 0, like having this here and not defining anything here, it's still the same. So when I say self dot length, it will go and create that attribute here. Okay, so it's the same. So like, okay, let's have it. So we have learned. So now let's create a new object of this room. So I will say dining room. So dining room equal to room. So I need to pass the length and the breadth. I can say 100 and I can say 80. So this is a classroom. It has two attributes, length and breadth, and we have a constructor. So what is a constructor? This constructor will be called whenever we create an instance of this class, or we create an object of this class, right? So when I create an object here, so this will get called, and I'm passing the length and the breadth. So if I print, let's say print, and let's say str dining room, and let's print wrapper dining room. Okay, so if we run this code, you see we have the same output for both of them. Why is that? Because if you can see, when we say star, it will go and look for this dunder star in this class. Def, we can have str. So let me just remove this part because we'll learn about this in later class. So here if I say return Pratap, if I say now, and if I run this code, so you see whatever I write here, it returns here. I say return Pratap, so in that case it returns me Pratap. To be specific, let's define both the star and the wrapper. You can say underscore underscore repr, and here let's return if the length is, you could say self dot length, and the breadth is, you can say self dot breadth. So here, so let's return a string, let's say f, and we can say, according to the Python documentation, a wrapper should always have the name of this class. Like let's say room. If you can see here, how did we define this room? We defined this room by saying room. Okay, and now I can have this round bracket. Now I can pass these variables. I can say, what I can say here is self dot length. I can say comma self dot breadth. Okay, so let's run this code. So now you see, when I say str dining room string dining room, so in that case what I get is, I see the length is 100 and the breadth is 8. So whatever I return here, I'm getting that. And for the wrapper method, so what am I getting? I'm getting whatever I return from here. So let's say for instance, we don't have this wrapper method. We don't implement this wrapper method. If we run this code, you see we have this default. We get this room. Okay. And for the other case, let's say we don't have this star method, and let's run this code. So now we get the same result. Why is that? Because our string function, it will go and search for underscore underscore str. So if it finds that, it will return whatever we are returning from here. But in this case, we don't implement the underscore underscore str. So in that case, it will go into this wrapper method. And if you see this wrapper method, we're returning this. In that case, it will go and return this value. But in the case where there is no star and wrapper, so in that case, we'll have the default, which is we have this room object at certain location. So let me uncomment this. So now you can ask me, when should I use str? When should we use this wrapper? So underscore underscore str is more user friendly, or if you want to demonstrate certain message to the user, then you should use this underscore underscore str. And if you want to give certain message to the developer, then we'll use this wrapper. So underscore this $str method is more user friendly, and this is more developer friendly. So this way we can understand about the magic method $str and $wrapper. So I hope I'm able to make my point. So here, what is the advantage of having this, the class name and the attribute? So let's say I have kitchen. So I want to create a new object. So what I can say is I can write this Python eval command. I can say wrapper dining room. So now if I print kitchen, you see this is kitchen. So this is basically the magic of wrapper and the store method. So we should always remember when we return anything from this wrapper method, it should exactly be same as like this. So whatever we are passing, right? So we have this room, the name of the class, and then we have this parentheses. So this is the parentheses to initiate the class, and these are the attributes which you are passing here. So far, we have learned how to use $str and $wrapper method in a built-in class and also in a user-defined class. And we also learned how exactly $str and $wrapper is different. The $str method is more user-friendly. Like if you want to give user-friendly output, then we should use this $str. And if we want to give developer-friendly message, then we should use this wrapper method. So far, we have learned about object-oriented programming in Python. We have learned about classes. We have learned about objects. We have learned about instance method. We have learned about different concept of all this object-oriented programming, right? So today, let's learn about class method, static method, and the difference between them. So let's get started. So to demonstrate this, so first I'll take an example of, let's say, from date time. Let's import date. To take an example, let's create a class called calculator. And let's have a constructor. So it will have def init, we'll say self.version, it's equal to, and let's take this input version. And for now, let's skip this part. So I'll talk about typings in Python later on. Let's say version. And then let's have a description. Let's say def. So now we'll have an instance method called description, which will basically say description. We'll say self, and here what we'll say is we'll print using the f string. We'll say currently the version of calculator is self.version. We have a class called calculator, and we are instantiating this class in the constructor. It's taking the version, and we're setting this version to the instance of this class, and we have an instance method. If the method inside this class have self in it, then we regard that as a instance method. So now if I want to create an object of this class, let's say calculator1 equal to calculator, let's pass a version of 10, and let's copy paste this, and let's have a version of 100, and let's say calculator 2. So now what we can say is let's print the description. Let's say calc1.description. So let me just copy and paste, and let's say calc.description. And if I run this code, so we see, so we have two instances. We have calculator 1, we have calculator 2, and we say currently the version of calculator is 10, and for the second calculator we have the version is 100. So let's say inside this class, let's have another method. Let's say def add numbers, and it will take self, and then so it will take two numbers. So if you remember, we have learned about unpacking an argument. So we can say args. So today let's use built-in function sum. So here we can say return, and we can use the built-in function sum. So what basically sum does is it returns the sum of a start value default plus an iterable of numbers. So this args is an iterable. So let's say here args, or we can name this as numbers. So if you can see this, we have two instance method. We have this description, and then we have this add numbers. But if you see, like in this description, we are using this self keyword. So what is self? Self is nothing but this object or this instance, right? But in the case of add numbers, we are not dependent on the instance itself, right? So why not? Let's just remove it. But if I click here, so it says here self@calculator. That means this is a static method. So what's a static method? So a static method is a method inside a class which does not have any association with the instance. So in this description, this is an instance method. So it has a association with the instance, with the current instance, right? But in this case, we don't have any association with the instance of this class. So we can just simply write like this. So let me just run this code. So now if I want to use this add numbers, I cannot do say calc1.add numbers. Let me print this because it done something. So we get an exception. Why is that? So it is because this is a static method. So we can't use it from the instance. So we need to use it from the class. So if I say calculator.add numbers, so in this case should run. So we don't pass any number. Let's say 10. So in the previous example, I don't pass any number. So you may say that because we don't pass any number, because of that we are given exception. No, we are not. Let's say 10, 11, and 12. Let me run this code again, and you see we still have the exception. Why is that? Because we are trying to access the static method of a class. This method doesn't have any association with the instance. We are getting an exception. But if I want to use this add numbers, I should use from the class rather than from the instance. So now if I say class name dot, if I access this add numbers, now I should be able to get the result. So you can say, why not we can directly use this, like we can remove this from the class and we can use directly outside, right? So that's your preference. We can have this function called directly, or we can have some utility for this. So now I prefer to write add numbers because it's something related to calculator. Or we can have some math class where we can add numbers like that, but I prefer to add here, right? So first, let's understand the difference between instance method and a static method. Instance method have an association with the class, but this static method doesn't have any association with the class, but with the calculator. So if I want to access this instance method, I need to create an instance. But if I want to access this static method, I want to use the class. As you are writing this code, you know that this is a static method. But if someone third person coming and reading your code, will they understand this is a static method? I don't think they will understand. But we can use the rate static method to say that this is a static method, so that any other developers who are coming and reading this method, they can understand that this is a static method. So this is the difference between instance method and static method. So to demonstrate the class method, so I'll comment this and I'll write another example. So let's say we have a class person and it has a constructor, and it takes self dot name equal to name, and it says self dot age is equal to age. As usual, let's remove this and let's say self and let's say name and age. And then we have a instance method here. Let's say def. So description, it will have self, it will say print, it will say f, let's use f string, and say self dot name is self dot age years old. We have this example, we have a person and we have this description. Let's create an instance of the class. Let's say Pratap, we'll say person, and we'll pass my name Pratap and my age is currently 20. So if I print the description, let's say Pratap dot description. So if I run this code, you can see that we have this Pratap is 20 years old. Okay. But let's have another one example here. Let's say we want to calculate age from the year. Okay, my age is 20, but I want to provide birth year here. I want to provide that flexibility so that the user can enter either their age or either their birth year. So in that case, what I could do is I can define another function. Let's say age from year, and let me just complete this and then I'll explain you. Take name, birth year. Okay, and here I will return the class, whatever I'm getting from here. So if you see here, I have something very different, right? So what is this? So let me just explain you what exactly it is. I'll add a class method decorator. We'll learn about decorator in the upcoming section. So if I say class method, that means that this doesn't have any association with the instance. But using this method, I can modify the class. How can I do that? I told you that we want to provide the flexibility so that the user can enter either their birth year or either their age, right? So how can we do that? Let's say current year. Current year is nothing but date dot today dot year, and what will be the age? Age would be basically current year minus birth year, right? So now I have the name, now I have the age, because this class accepts age, right? So what I can say is I can return the class. So what is this class? I don't know now yet, so let me just use it. Let me say name and let me pass it age. So earlier when I instantiated this object Pratap, I say I was calling person and I was calling Pratap. I was passing the name and the age, right? Now what I want to do is I want to create an object. Let's leave it Pratap. Let's use Madhav. So Madhav is equal to, now what I can say is I can say person dot age from year. Okay, and here then I can pass Madhav, and he's very old, he is 35 years old, and let's say Madhav dot description. Let me run this code. Did we do something mistake? Oh yes, we did, because we should not pass the age, but we should pass the birth year, right? So Madhav is of 1990. Let's run this code. So he's 33 years old. But we are instantiating the class like differently, right? We instantiate here by using the class name, but here we use the class method. How does that really works? Here, if you can see, we are accessing this class age from here by using the name of the class as we did in the static method. But how is this different from static method? Because it is having access to the class. So what's the class? Here I'm using person.age from here. That means when I get the class here, I'm getting the person class. Let's print that. Let's say CLS. If I print this, you should see we have the person class. That means whoever is calling this method, that particular class will be get passed to this CLS. So in that case, what is the CLS? This is basically person. So instead of writing like this, so this is very bound, we are hard coding it, right? Like let's say in the future section, we'll learn about inheritance. So we'll learn more about that in there. So let's say we have inheritance and we are using here, let's say here we're saying human. But now we are hard coding here, right? But we want here human. So in order to avoid all those things, like we are not hard coding here, we are using the class method, which we are getting, like which we are passing from here. So now whoever is calling this method, we are instantiating for that particular class. So I hope I'm able to help you understand the difference between the instance method, the class method, and the static method. So far, we have learned about the difference between the instance method and the static method, how we can call the instance method, how we can call the static method, and also we learn about the difference between the static method, the class method, and instance method. And here we learn how we can create an object based on the class method. Here we are creating an object of this class, and ultimately we are having the same result, like even using the instance method by creating an instance of that class, or by using the class method, we are creating the instance and we are still having the same type of behavior, correct? So what's the advantage of this class method here? We have gave the flexibility for the user to create an object based on their birth year or their age. So I hope I'm able to help you out with all the concepts, and let's learn about it in the upcoming section. Welcome back. So nice to have you here again. So into this session, let's learn about inheritance in Python, and let's get started. So first of all, what is inheritance? So inheritance, it's like passing special features from one generation to another. So let's say we have father, son, and grandson. So here, this father, he has a land of 1 acre, and then this land is being passed to his son as an inheritance. So now the son is also the owner of this land, okay? And also this son also had a son again. So now the new grandson also have this special feature, right? This 1 acre land. Basically, inheritance is nothing but passing down of special characteristic from one level to another level, one generation to another generation. So in Python, how do we work with inheritance? So let's say we have a class, a base class. So in this case, this father is a base class here, or a super class in Python. So the new class in this case, let's say we don't have grandson. So in this case, like father and son, in the case of this father and son, so father is the super class and this is the subclass, okay? So in Python, we have this superclass. In this case, it is father. And then we have a subclass. In this case, it is son. So we are getting an error. Let me just say pass so that we can avoid this error. It should be father. And I can say here father. Okay. So this means that this is a class which is called a superclass. So this will have certain feature. So in our case, we can say a father has total land. If I say he has 300, like let me use it in a string, let's say 300 acres, right? Now if I create an instance of this son, let's say son equal to son, and if I print son dot total land, if I run this code, you see we have 300 acres. But we didn't write anything here, right? How does that work? That means, so this class son has passed down some special feature of this father, okay? Also, let's create a new object of father. Let's say dad equal to father. Let's print dad. Let's print dad dot total land. Let's run this code again. And you see we still have 300 acres. That means father has some features, some attributes or some methods. So that attributes will get passed to the son or to the subclass. So this is a superclass. So this is a subclass. Okay. So let's define a print method. Let's say def print, let's say display, right? Because we may mix up with the print method. So let's say display f, the total land area is, now let's say how much. So we should have self here, right? Because it's an instance method. Let's say self, then we should say self dot total land. So now what I can say, let me remove this code, but let me just comment it. Now what I can say is, I can say son dot display, I can say dad dot display. So let's run this code again. So you see, we have the total land area is 300 acres and the total land area is 300 acres, right? So let's remove this pass now. So let's have another method here. We'll say girlfriends, right? Or we'll say number of girlfriends equal to 2. So now I can have here another instance method. Let's say print gf girlfriend count, right? If I say this, let's have itself here. Print the number of gf are, let's say, self dot number of girlfriends. So if I say son dot print gf count, so this in this case, so if you can see, where do we define this print gf count? Where is this instance method? So this is present inside the class son, right? So if I run this code, so you can say the number of girlfriends are 2. But if I try to do the same with, now you see, father object has no attribute print gf count. That means only the attributes from the superclass will be passed down to the subclass, but no properties or no attributes from the subclass will be passed to the superclass or the base class. Okay, so this is a concept of inheritance. So let me take another example. So let me comment all these. Okay, so let's create another new class. Let's say class polygon. Let's have a constructor here, def init, and you can say it will take number of sides. And here let's say self dot number of sides equal to number of sides, and we can say self dot sides is equal to 0 for I in range number of sides. So let's say we have each sides. So number of sides in polygon can be 3 or more. So let's say we have 3. Then if the number of sides is 3, so we create a range from the number of sides and we assign initial value to be 0 for each of the sides, right? So now let's take an input. Let's say def input sides self. So what will this method do is it will take a user input and the user will be able to input the size of the sides, right? So what we can say, let's say self dot sides is equal to, we'll use list comprehension. So first let's loop through the range. Let's say for I in range self dot number of sides. So let me just copy this. Okay, so now what I can say here is, let's say for each of the side, let's say float, let's convert it to the float, and let's say let's take the user input and we'll say enter the side, and we can say, I think it's better to use an f string. Let's say f string, enter the side, and we can say str, and let's say I plus 1. So what we can say is, let's say like this. Okay, so that means what we are doing here is we are taking an input for all the sides. Let's say the number of sides is 5, then we are taking the input of 5 sides. Let's say we have a number of sides is 3, then we are taking an input of 3 sides. So this will make sense once we execute this function. So for now, let's continue. Let's have another method which will display the sides, right? Let's say def display sides self. So we can say for I in range self dot number of sides, and we can say print, we can say f string side I plus 1 is, and let's say self dot sides of the index. Okay, so here let's have a deep understanding of what exactly this polygon is doing. So we have this polygon class. Basically, when we initialize this polygon class, it will take a number of sides. So for each number of sides, we are assigning a sides with a initial value of 0. Okay, we also have a method of input sides. Basically, what will this do is it will take an user input from the, like, it will take the size of the side from the user, it will take an input and it will save to the sides. Okay, and then we have another method which says display sides. So what will this do is it will basically go and display the sides. Okay, now let's create a subclass. So this is a base class. So let me just add a comment here, base class. Now let's have a subclass. Okay, so now let's create another class. Let's say class of triangle. It will inherit polygon, and inside this let's create a constructor. Init will have a self, and we'll say polygon dot init will pass self, and will pass the number of sides in triangle is 3, right? So now let's define a method that will print the area. Let's say find area. It will take self, and let's say a comma b comma c equal to self dot sides. So what we're doing here is we are using the property destructuring. So we are destructuring the sides because we have said triangle will have 3 sides. So we have used destructuring and we are assigning the sides to a, b, and c. So now let's calculate the area. Let's say side is equal to a plus b plus c by 2. This is a formula to find the area of triangle. So we can say s into s minus a into s minus b into s minus c to the power 0.5. Okay, so if you can see, we have this, we have find the average side. So basically this is a formula for calculating the area. So now we can say, let's say print the area of the triangle is, you can say percent 0.2 f, and you can use here percent area. Okay, so now we have a base class of polygon. It has certain properties, and we created a new class triangle, which is also a polygon. It will pass down the feature of all polygon, but it will have its own method of finding an area. Okay, so let me just add a comment here. So this is semi perimeter, and here we are calculating the area by using the Heron's formula. Okay, so now let's create an instance of the triangle class. How can we see that? So it's very simple. It's t is equal to triangle, and then now what I can say is t dot input sides. So I need to give the sides, and now I can say t dot display sides, and I can find the area, t dot find area. Okay, so that means from where did we get this input sides and this display sides? We get this from the polygon class. We are inheriting it, so we'll get those, all those properties. And where did we get this find area? We get this find area from the subclass itself, from the triangle class itself. So let me run this. I did some typo, so it should be here number of sides. So sorry for that. And let's run this code again. So now let's enter the side. So the first side will be 10. The second side will be 30, and the third side will be 12. But here it says that must be a real number, not complex. So I think we did a mistake somewhere here. Okay, so let's run this code. Let's enter the side. Let's say 10, 12, 13. So you can see the side 1 is 10, side 2 is 12, and side 3 is 13. And the area of the triangle is 57. This is the magic of inheritance. So I can define the method in the class itself. I can inherit the methods from the base class. So these are the benefits. Okay. So let's say in this polygon class, in the base class, we have this display sides, right? So now I want to display this side. I want to implement the sides by itself here. So let me say def. So I can write display sides. So here, instead of displaying the sides like this, I want to display the sides in, let's say, print the sides are, and I can use self dot sides. I just want to print the list of the sides, right? So if I run this code, let's say again 10, 11, 12. So now you see the sides are 10, 11, and 12. So I am overriding the method of the parent class in the base class. Okay, so this concept is called method overriding. Okay, so we can also use the super keyword. What we can say here super, and we can say dot display sides. So now I can also call the methods from the parents and also have its own implementation. So let me run this code. So let's say 10, let's say 11, let's say 12. Okay, so here you see. So we are getting this from the parent, but we are getting this from the child, which is a base class, right? So this way we can also use the super keyword. So when we say super, it basically means the parent class. So in today's session, we learn about inheritance is, what superclass is, what a base class is. We also learn about inheritance by taking example. We have a class son and we have this father class. It has certain attributes and the son was able to inherit those attributes. And also we take an example of another class called polygon. We learn how we can reuse the code. So we have certain methods here. And in the base class, when we create an object, we are able to access all the methods defined in this base class. And also we are also able to override the method and also call the super methods by using this super keyword. Welcome back. So in today's session, we'll learn about class composition in Python. So let's get started. So in order to understand class composition in Python, so let's get started by creating a class. Let's say we have a class salary, and let's have a constructor here. Let's have init. It will take self and it will take pay bonus. And here what we'll say self dot pay is equal to pay, and self dot bonus equal to bonus. Okay, and also let's have an instance method which will calculate the annual salary. So it will have self, and let's say return, you can say self dot pay into 12 for annual, you need to find for a year or for 12 months. You can say self dot bonus. Okay, so here we have a class called salary. It has an initializer, a constructor that takes two parameters, payment and bonus, and we are assigning the pay and bonus in the class attributes. And then we have instance method, which basically calculates the annual salary. Okay, so now let's create a new class, another class called employee, and here we'll have a constructor again. It will have self, it will take name, it will take age, it will take pay, and it will take bonus. Correct. So here let's say self dot name equal to name, self dot age equal to age, self dot. So here, since we want to have salary of this employee, right? So we can say obj salary is equal to. So here what we can say is we can instantiate this class. We can use this class here. We could have inherit it, right? Salary, but the employee class and the salary class doesn't have any, what we call, like employee class is not a salary class and salary class is not a employee class, right? Salary is not employee and employee is not salary. So because of that, we can't inherit it. So here let's say salary, and to instantiate this salary, we need pay and bonus, right? Which we are already getting in this employee constructor. So let's say pay and let's say bonus. Okay, so here let's have a method that will calculate the total salary of this employee. Let's say total salary. So here what we can say return. So since we have this salary object here, so we can simply say self dot obj salary dot annual salary. So this way we're able to access this annual salary, which is the instance method of this salary. So to understand this, let's create object. Let's say emp equal to employee. This will be basically Madhav, and he is 33 years old and he earns 15,000 a month and he gets bonus of 10,000 a year. Okay, so here what I can say print emp dot total salary. So here what we have done is like we have created two classes. One is a salary class which takes pay and a bonus to be initialized, and we have another class called employee. It takes name, age, pay and bonus. So let's run this code and let's see what we get here. So here we get the total salary of this particular employee Madhav. Okay, so what exactly did we do here? Here what we have done is, in order to have the salary, calculate the salary, we instantiate this salary and then we assign it to this object salary. And when we have to calculate total salary, we are accessing the instance method of this object, basically the salary object. So that way we're able to calculate the annual salary. So here we delegated the logic to calculate salary to this salary class, right? Whenever we want to delegate some responsibilities of one class to the another class, so that is called a composition. So this is what we call composition. So here we are delegating some responsibilities. Okay, calculating salary is not his responsibility, right? So we have delegated the responsibility of calculating the salary to this salary class. This is called composition. So I hope I'm able to help you out with understanding the concept of composition. So let me repeat once again. Whenever we have to delegate some responsibility of certain class to another class, therefore that is called composition. In today's session, we'll learn about type hints in Python. So we have been ignoring all these types in the recent videos. So we'll be finally learning about it. So let's get started. So basically what are type hints in Python? So let's say we have this method greet and we have this name and we have say str and we have a star, right? So here it means that this function greet, it takes an argument of name which will be of type string and it will return type string. So when we have this arrow and this str, it means this the return type of this function and this is the type of the argument. Okay. Type hints was introduced in Python 3.5 from Python version 3.5. So up until now, we could have sent anything in our Python function or the return type, so we cannot define those things. So it's very difficult to know exactly the return type of the input type of that function. But having this, it doesn't really change Python core principle. So Python is still dynamically typed language. So here, let's say print, let's say greet, and let's say learn with Pratap. So if I run this code, you see we have this hello learn with Pratap, so it's still the same, right? So but now if I see greet, you can see here we have the return type of string, right? So this way, other developers who are working on your code base also would understand like what exactly this function takes. Okay, so let's have another function. So we have this function headline. This headline, it takes two arguments. It takes one is the text and the other is a line. So if you can see from here, text is of type string and a line is of type true, right? So how can we give the type here? And also if we see it's returning some string, right? How can we see that? So we can add types by saying colon in the type. So the type of this text is string, so as we'll do str. And what is the type of this align? So the type of this align is basically bool, right? So you can say bool and the default value. Since this function returns a string, so we can say like we can define the return type by saying this dash and this arrow, right? And then we can say str. So this way we understand what exactly this function does. It takes a string and a boolean and it returns as a string. So now if I say print headline, learn with Pratap, print headline, learn with Pratap and false. So we have default argument as true. So you see now it is very easy to understand like what exactly this headline does, right? It takes two arguments, one of type string, one of type boolean, and it returns as a string. So this is a type hinting. So here is a style which Pep 8 recommends. So we should use normal rule for colon, that is no space before and one space after the colon. You can see we don't have any space here before the colon, but after the colon we have one space. And then we need a space around the default argument. Like let's say we have this and this, right? So we have spaces. You can see use spaces around the equal to sign when combining an argument annotation with an default value. So we have here space and then we have here space. Use space around the arrow defining headline str. So here we're having this space around this arrow. So these are the styles which are recommended by Pep 8. So far we have learned about type hints in Python. We learned when it was introduced. It was introduced in Python 3.5. We learned how we can convert the existing function by having the type hint. And we learned the benefits of type hint. And also we learned about the styles which is recommended by Pep 8. Welcome back. So in today's session, we'll learn about modules in Python. So let's get started. So what is a module? So module is basically a collection of code which are placed in a single file. So if we see our previous examples, so you see this code grows very long, right? So the number of lines in this code is 70. As we add more functionality into this file, the number of line will keep on increasing. So in order to minimize that, we can have modules in Pythons. So what's a module? So a module is a file that contains code to perform a specific task. So a module may contain variable, function, classes, etc. Okay. So let's see an example here. Let me create a new file and let's say example.py. And here let's have one function. Let's define a function def add. It will take all the arguments and then we'll say return sum. And we'll add all the arguments. Okay, so we'll say return sum args. Okay, so we have this module. It has some functions. Okay, so we say that a module is a file that contains code to perform a specific task, right? So this module contains add which will perform a specific task. So now I want to import that module here in this code.py. So what I can say import example. Okay, so here are what I can say print example dot. We have add and let's pass few numbers here 10, 12, 13. And if I run this code, so you see we get the sum, right? Also, if you don't believe me, let's add print here and let's say I am from the example file. Let me run this code. So it says I'm from the example file and it means 35, right? So this is a user defined module. You remember earlier we used date, we used date time. So this is also a module. Okay, so this type of modules are called built-in modules. So it comes with the Python. Okay, and the one which we import, let's say import again, let's import example. Okay, so this is a built-in module and this is a user defined module. Okay, so let's use this date time. Let's say print, we'll say date time dot now, and let me run this code and you see we have this date time. So we're using this built-in module. So here, let's say we have so many methods here. Let's say add, let's say for another method called add1, and let's say for another method called add2. Okay, so we have these multiple functions in this example.py. From that example, I just want a single function, which is add1. If I want to import specific functions or specific class, so what we can say? We can say from example import add. So I can also say this way. So if I run this code, it will still work. You see? So this type of import is called from import. So we can do the same with datetime. We can say from datetime import datetime. And now I can directly use datetime. And if I run this code, it still works. Also, let's say we have here datetime, right? So let me comment this. We can also import and everything. So I don't want to import just add. I want to import everything. Okay. So if we want to see which all modules are present in this, let's say I can directly say add. If I run this code, it should still work because I've imported everything from this example module. So I'm able to access this add. So if you want to see which all modules or which all functions or methods like we are having access to when we do like this, to check that we can say print and we can say dir. So if we run this, if we just do this, if we run this code, we will see all the function names in this module. So we have add, we have add1, we have add2, we have datetime, and we have all these other things. So all the names defined in our current namespace can be found out using the dir. Okay. So if I want to specifically find for this example, so I can say import example, and if I run here example, and if I run this code, I will see all the functions or all the built-in modules and function of this example. So in this case, we can see add, add1, add2, and then we can see all the other dunder methods. So these are basically modules in Python. So why are they useful? They are useful because we can distribute our code based on the principle. And then we can place the code in different modules. Let's say we can place math related calculations to a math module, and we have different business logic in different modules. So this way we can have a separation of concerns, and then we can make our code more organized, which will be helpful to debug. Okay. So I hope you find this helpful. Hello, welcome back. So in the previous session, we learned about modules in Python. So today, let's learn about the different types of module, how we can import them. So let's get started. So in Python, we can import modules in two different ways. So one is called absolute import and the other is called relative import. Okay. To start with, I've created certain packages and I've created certain modules. So in Python, a folder is called a package and a file is called a module. Okay. So what I've done here is I've created package 1. I have two files inside this package 1, basically two modules in this package 1. I have sub package in this package 1, and that sub package has a sub module. And then I have another package 2, which has two modules in it. So let's quickly go and add a function in each of the modules. Say dev run, we'll say file 1. So yes, I've added this run function in this root file, and then I've added one function each in of this module. Like we can say run file1 package 1, and it says I am file1 package 1. I've added in all the sub modules. I've also added in the modules of this package 1 and then package 2, right? So now let's say from this root file, I want to call file1 package 1. So how can I do that? So let's say we can say from, and we want from the package 1 file 1, right? The module 1. So we can say from package 1 import, what we can say now? We can say file1 package 1. File1 package 1, correct? So now here what I can say is I can say file1 package 1 dot run this one. So if I save and if I run this code, I can say python 3 and let's say 27 and root file.py. So why don't we get anything? Because I didn't call this run function, right? I need to call this function. So let's say run. And let's run this code again. So you see, we have im root, and this root file is calling this im file1 package1. So in absolute import, what we have to do is we have to import by using the package. So in this case, we're using package1 import file1 package1, correct? So let's go to file1 package1. For now, let me close others. So here in this run file1 package1, I want to import the module from this file2 package2. So when I do that, I can say from package2 import, what can I say? I can say file1. I can say file1 package2, right? So here what I can say is I can say file1 package2 dot run this one. And let's run the code again. You see, we have im file1 package2. We are able to call this using here. Also, let's try to call the module from this sub package. To do that, what we can say from package1. So here, so package1, we have this package. So inside this package, we have another package, right? We have a sub package. To do that, we can say dot sub package1. We can do like this. I can say import. What I can say here, so it has a big name. You can say, so let me just copy this. So I can say import. So now if I call the function from that file1 sub package1 dot run, and if I run this code again, you see, we have im file1 package1 sub package1. Okay. So from this root file, we were able to import this file1 package1, and from inside this module, we have a function here. So in this module, we were able to import package2, we were able to import package1, and so on, right? So this way of importing using the package is called absolute import. So now let's learn about relative import. So to learn about relative import, what we should note is, so let me just comment these two imports and let's try to replicate the same. Okay. So what we have to note here is, so in relative import, you need to know about this. Like dot means current package. Okay. And dot means the parent package. So in this case, I want to import package2 from, okay, how can we say that? So let's try to replicate the same. Let's say from, I've got one step above, right? I think for this case, if I want to import package2, or let's import this package1, let's say from sub package1, import file1 package1 sub import 1, right? So now let me just comment this code and let me run this code again. So we're able to run the method here, right? So now let's try to import this package2. So let's say from dot package2, we'll say import, what do we want to import? We want to import file1 package2. Okay, so now let me uncomment this code and let me run the file again. So let me run this code again. So but here we get an error. So why is that? Because we attempted to import beyond the top level package. So we can use relative import only in the packages, not in the root level. So here what happens is, in this file I try to import the package from the root. You see, package1 and package2 lies in the root directory. Root means this is the root directory, the parent directory. So inside this directory, I try to import the module from the package2, which is in the root directory, right? So that's why we're getting that error. Okay. So in Python, we cannot do that. Let's take another example. Let's comment this, and let's go to the sub package. Here, let's try to import this file2. Okay. So here, let's say from, I want to import file2 package2, right? So I'll say file2, I want to import file2 package1. Okay. Or what I could say is from import. So let me copy this and go to this file again. Now let's say file2 package1 dot run file2 package1. So do you think we'll be able to run this code? So we're in this sub package. So we are running this sub package here. So let's run this code. So yes, we are able to run the file2 package1 from the file1 package1 sub package1, right? So if you understand correctly, so why am I able to do dot here, but why I was not able to do dot here in this case? So the reason was that when I do dot here means for this sub package means package1. So this package1 is not a root directory. But in case of this file1 package1, when I say dot means I'm in this root directory. Try to access the root folder. So in Python, it doesn't allow us to do that. So in Python, we have this __ init _ py. So from Python version 3.3 and above, so we don't really have to put this init.py in the packages. But like before Python 3.3, in order to make a folder a package, we had to place this init.py in the package folder. So let's say So it should be .py. So when I say dunder_init.py, so that means that now package 1 is a package. So this folder package 1 is actually a package. So this was required before Python 3.3, but after Python 3.3 or above, like we don't really need it anymore. So let's skip for now. So far, we have learned about how we can import a module in different packages, in different files. We learned about what absolute import is, what relative import is. So when we import anything by using this package, it is called an absolute import. And whenever we import a file using this dot or dot dot, so that is called a relative import. So now, like, when should we use relative import? When should we use absolute import? So we should use absolute import when we know that the modules or the folder structure will not change. In that case, we can use absolute import, because, like, let's say we are using absolute import in this case. We try to place this file somewhere else, so that in that case, that whoever was consuming this file, they will throw an error. Okay. So we should use absolute import only if, like, our folder structure doesn't change much, and we should use relative import if we are in the same level. So for this case, from this file 1, if I want to access file 2, package 1, so in that case I can directly use relative import. Okay, so I hope I'm able to help you out with all this, understanding the absolute import and the relative import. So in this session, we'll learn about exceptions in Python. So let's get started. So what is exception? So exception means when there is a specific logic of code that breaks. So for example, let's say we have num1 equal to 7, and we'll say num2 equal to 0. So when we try to divide these two numbers, let's say print, and I'll say num1 by num2. So if I run this code, you will see that we'll get an exception, because this is not possible, right? We cannot divide 7 by 0. So in that case, our code breaks. It throws an exception and says 0 division error, and it says division by 0 is not possible. So here, 0 division error exception, it's a built-in exception. So there are a bunch of exceptions that can be thrown by Python. So let's list all them. So to list them, we can say print, we can use this dir function, and then inside this dir function, we can say locals. Locals will give us all the built-in modules and all, and we can say here in string, we can say built-ins. Okay, so let's run this code. So if you can see, like, when I run this code, this print never executes, right? Because our code breaks here and it doesn't go forward again. So there's a problem of exception. So now let's comment this and let's run this code again. So now we'll have all this type of different exception that can be thrown by our Python code. So all these exceptions are built-in exception, arithmetic error, assertion error, attribution error, etc. We'll learn more about exceptions in the next section. We'll also learn about user-defined exception and all. But for now, how can we handle this type of exception? Like, let's say when I say print num1 by num2. So when I run this code, I want to print learn with Pratap. So how can we handle this? So I want my code, even if this fails, I want to run this code. How can we do that? So in order to do that, any Python code that may throw exception, we need to add them inside this try except block. So something will be here and we'll say except. So here, let's put this inside this try. So we put this print inside this try, and let's print the exception here. So let's say I cannot divide. Okay, so let's run this code again. So now you see, even though this num1 by num2 throws an exception, we're able to handle it, like we have handled it, and the block of code goes on to the next line, right? So we're able to print this. So this way we can handle the exception. So here we can accept the specific exception. So in this case, we can get 0 division error exception, like let's say E. So if I say just this one, if I can, like, if I run this code again, you can see we just have this I cannot divide, but we don't know what exactly the error was, right? So we can accept this and extract it as E. So now I'll say I cannot divide E. So we'll get the message here. Okay, so let's run this code. So now you see it says I cannot divide division by 0. This way we are getting a exception. So now let's say we have another list. Let's say list my list, and it will have just 2 items, 1 and 2. And if I try to, like, let me just comment this, and if I try to print the my list of third index, it doesn't exist, right? So in that case, if I run this code, it throws an error and it doesn't continue, because we try to catch the error only for this 0 division by error, right? We want to catch the error for this specific. So for that we can say except. So we can say here the index error, we can say index error as E, and you can say print E. Let's run this code. So now you see we have list index out of range. So this way we can get specific errors. Okay. Also we have an else block here. We have else print I am else. So when will this run? If you see, it doesn't go to the else, right? Because there was some exception. So in this case, let's say just 2, let's run. So it doesn't go in the exception, right? Let me comment this part and let me try an exception again. So when will this else block execute? Like, let's say, let's write it correctly. So we have this one. And let's run this code. So now you see we have this I am else also. So if we have anything inside this try block and it doesn't throw any exception, so in that case it will go to the else block. Okay, and then we also have another finally. So finally, let's print I am finally. So let me run this code. And you see we have this finally. This finally will run even there if there is an exception or if there is no exception. So in that case, let's try to throw an exception. Let's say this. So you see we have this finally blocks been executed. So let me run this code again. Now we have a well working code, right? So let's learn what exactly we have done in this exception section. So block of code may throw an exception. To handle those exceptions, we can use this try except. Okay. So here we can use a specific exception, or we can get all the exception in once by saying exception. Let's say E. Let's say print E. Okay. So here, if there is any index error, like if there is any index error exception, then this except block will catch that. If there is any zero division error exception, then this block of code will check. If we don't handle the exception for a specific type of exception, then that will go into this exception block, because we are catching all type of exception, because all these exceptions are inheriting this exception. Okay. If our code runs successfully without any exception, then in that case, we will run this else block. Like, let's say if there is no exception in the code, we can write there was no exception in the code, right? So in that case, we can use this else block, and this finally block will run in either of the case, even if there is exception or even if there is no exception. So in the both case, this final block will always run. So when can we use this final block? Let's say we have a DB connection open, and if there is any exception there, I want to close the DB connection. If I successfully read the data from the DB, in that case I want to close the DB connection, then I can put that block of code in this finally block. So these are different types of exception in Python. So far we have learned about built-in exception in Python. So in the next module we'll learn about user-defined exception. So we are currently learning about exceptions in Python. So in the previous section we learned about built-in exception in Python. So today we'll learn about user-defined exception. So in the previous section, we learned about different built-in exception and why it was important to handle exception. Okay. But sometimes we may need to create our own exception that serves our purpose, right? Like, let's define an exception, user-defined exception. In Python, we can define our user-defined exception by saying class, we can say custom error, and this will extend the exception class. Okay. So here we can have some body, and then we can use this try. So here we have some block of code, and then we can accept. Here we can say custom error. Okay, so if you see here, so this is a custom error or user defined error. A custom exception or a user defined exception has to inherit this exception class. So this custom error is a user defined error which inherits from the exception class. Okay, so when we are developing a large Python program, it is a good practice to place all the user defined exception that are programmed in a separate file. So this is how the user defined exception would look like. So let's try to create a user defined exception. We'll take an user input, and if the age of that user is less than 18, then in that case we will throw an exception. Okay, so let's define the exception. Let's say class invalid age exception, and we have to inherit the exception class. Okay, so here we'll just simply say pass. Okay, so let's use try, and let's say user age, we'll say equal to int, and here we could say input, and we'll say how old are you. Okay, and here we'll say if user age is less than 18, we'll say raise invalid age exception. Okay, else we'll say print you are permitted to do some works, and here what we'll say, we'll accept and we'll catch the invalid age exception, and then we'll print exception occurred, invalid age. Okay, so here we have created a user defined exception. So we have said invalid age exception, it inherits the exception class, and then here we have taken the user age from the input, and if the user age is less than 18, then in that case we are throwing this exception, or we are raising this exception. We can throw an error by using this raise keyword. Else, if the age is not less than 18, then we say we are permitted to do some work, and we are catching that exception. So let's run this code. So let's say I am 10 years old. So it says exception occurred, invalid age. So let's run this code again. Let's try to give 19. Then it says you are permitted to do some work. Okay. So in this example, we have defined the custom exception invalid age exception by creating a new class that is derived from this exception. And when the user age is less than 18, we are throwing the exception, or we are raising the exception. And then when an exception is occurred, the rest of the block of code will be skipped. So let's try to customize this invalid age exception. So if you want to customize this, we can have the constructor of this class. And let's say init, it will take self. Okay. And then it will take a message, and the message would be basically, let's say you must be 18 years and above. Okay, so here what we can say is, also let's take the age, say age, and then we'll say self.age is equal to age. Okay, and here what we can say is, we can have this customize this exception by calling the super. Okay, so for that we can say super. So we are calling the parent class exception, and in that case I will call the init of the parent, and here I will pass the message. So here what I can say, let's say self.message is equal to message. So in this case I can pass the self.message. Okay, so now it says that you are not permitted to do some work. Okay, so if I don't write this, let's say let's not have this try catch block, let me just comment this. Let me copy and let me uncomment it. So, and let me remove all the try block. I don't really need it for now. Let's reindent it, and then let's run this code. So let's say I am 17 years old. Okay, so here, why is that? Because I don't have this age. I need to pass this age. So maybe I can say here, let's say user age. So let me run this code again. Let me say 17. It says that invalid age exception, you must be 18 years and above. So in this case, we have overridden the constructor of the exception class to accept our own custom arguments. Okay, so it has taken this salary and message, and we are throwing the message based on that. Okay, so the constructor of the parent exception class is called manually with the self.message arguments using the super. So we are calling this manually. Okay, so far we have learned how we can create a user-defined exception. To create a user-defined exception, we need to inherit the exception class. We have learned how to create an invalid age exception and simply do nothing, like simply pass. So let me just copy and paste it here. So you will have to, let me comment this, and in this case we just had pass. So here we were just using the exception class, whatever it was doing, we were okay with that. But in this case, we were sending our custom message as well. So to send the custom message, we need to call the super init and with the custom message which we want to send. So here we have a message called you must be 18 years and above for this particular exception. And now when the user inputs the age which is less than 18, then in that case we are throwing this invalid age exception by passing the age. In today's session, we'll learn about Python first class function. So why are function call a first class function in Python? So we'll learn about that. So let's get started. So in Python, why is functions called a first class function in Python? So let's define a function double number, and here we'll say return num into 2. So we'll double this number. Okay, so now let's say let's have this variable. Let's say my double is equal to double of some number, let's say 5, and let's say print my double, let's print double. Okay, so here I've defined a function double. It takes a number and it returns twice the number. So if I run this code, you can see here I have a variable my double. I've assigned the output of this function to this my double, and then I print the value of my double and I print the double here. You can see I pass 5 in this double and the output is 10, and I print the double, which is basically the function. So it gives me the object of this function. So now let's say we remove this parenthesis, okay, like this function call. If you remove this, and let's run this code again. So we see the same object address for this, both my double and the double. That means we are basically assigning the function double, the object of this function double, to this variable. So now I can directly call my double and pass 5 here. I'll get 10, and I can pass 5 here and I'll still get 10. You see, that means I'm assigning the function double here, but I'm not calling the function here. Like I'm not calling the function. but I'm just assigning the function. But here, when I assign this function to this variable, now this variable is also a function type. So now I can call this variable. Okay, so this is the first pillar for a function to become a first class function. Okay, so let's take another example. So now let's try to have a higher order function. Let's say def. So I defined a function shout. It takes text as an argument and it converts the text to an uppercase, right? And here I defined a function whisper. It takes the input as a text and it just converts the text to a lowercase. And then I define a third function which takes a function as an argument. And in line number 17, you can see we have called this function, we have passed the text, and we are assigning the output to this variable greeting. And here we are printing the variable greeting. Okay, so we can say greet is a higher order function. So this is a higher order function. So this function greet is a higher order function. Why is that? Because it takes a function and it does something right here. Now let's call this greet. Let's say greet and let's pass shout here. You see that I don't call this shout. I don't call the function, but I just pass the shout. That means I'm passing the function shout here. Okay. And let me run this code. And you see, we see here I there. So when we call this function greet, so I call this function and I pass a function as an argument. So I pass this function as an argument. So if I print this func, and if I run this code, you can see I have this function at certain address, right? So this is the object of this function, right? So that means I can call this function. So let's run this code again. So we get a function here and we are calling the function from this, like we are calling the function here. You see this parenthesis? And we are passing this text. So when we call this function, that basically what is this function for current scenario? So the function in this case currently is shout. So that means I'm calling the function shout. So that means in this case, it is shout, it is shout. So basically it is calling this shout function. Okay, and then what does this shout function takes? Like it takes text as an argument and it returns the by converting the text to an uppercase. And here what would be the output? It would be hi there in capital case. So greeting will be in capital case, hi there in capital case, and we are printing the value of greeting. Correct? So let's change this shout to whisper. Now you see, we see in all lowercase. That means now currently I call this greet function. Now I pass whisper as a function here as an argument. I will pass whisper function as an argument. And then here we call this function and whisper, it takes a text and it converts the text to a lowercase and it returns. And now my greeting is basically hi there in lowercase. And then we print the greeting. Okay. Now let's have another example again. So we have this parent function. Also, we'll have two other function. Let's say, let's define another function. That's another two function. Let's say def. Hi, I'm Pratap. Hi, I'm Madhav. So here we define first child function. It basically returns hi, I'm Pratap. And here I define second child function and it returns basically hi, I'm Madhav. So now inside this parent function, so let's say if num equal to 1 will return first child, else will return second child. Please note that I'm not calling the function. I'm just returning the function. Once again, please note that when I call this parent function and like when I return this, I'm returning the function and not the function call, right? I didn't call the function. I'm actually returning the function. So now let's call this parent. We can say my parent is equal to parent and let's pass 2 and here let's print my parent and let me print my parent also and let me run this code. Okay, so here let's see what we have done in line number 35. We call this parent function and we assign the output to this variable my parent, right? So when we call this parent with the argument 2, let's go to this parent function. So we get an argument of 2. So here num is equal to 2. Is num equal to 1? No, it's not, because num is equal to 2. And then it goes to the else block and it returns the second child. So here please remember that I'm not returning the function call. I'm returning the function object, right? If you don't believe, let me print here second child. So you see, the second child is basically like when I return here, I return the function object, not the function call, right? So in that case, when I return this some child, like second child in this parent function, so now the value of this my parent is now the function second child. So when I print my parent here, in that case, this is a function. I'm not calling the function, but in line number 37, you can see I call this function using this parenthesis. So in that time, I'm executing or I'm calling that function. So I return a function here and I'm calling the function here. Therefore, I get hi, I'm Madhav. So if I pass 1 here and if I run this code again, you see here, I see hi, I am Pratap, and now the object is of different location. That means I'm returning a different function. So this type of function is called higher order function. So what is a higher order function? A higher order function is a function that takes a function as an argument and returns a function. Okay, that means here if you see this example, it takes a function as an argument. And here in this case, it returns a function. Like when I call this function, it returns a function. So let's see the difference between returning this first child like this and return the second child like this without calling it. So the difference is parentheses. So can't call this function because this is not a function anymore. This is a string here, right? If you don't believe, let me comment this. So I don't have to comment. We already have here, hi, I am Pratap. When I return like this, I call this function and I'm returning the output of this function. Okay. But when I say return like this, so I'm actually returning the function and not the output of the function. So I hope I'm able to help you with understanding the higher order function. Why do we call first class function? So these are the 3 pillars of first class function. So one pillar is we should be able to assign a function to a variable, okay? And we should be able to pass function as an argument, okay? And the third pillar is we should be able to return function from a function. So these are the 3 pillars that should be satisfied in order to call a function a first class function. Welcome back. So in the previous session, we learned about Python first class functions. So using that concept, we'll be learning about decorators in Python. So let's go started. So what's a decorator? A decorator is a function that takes a function and returns it by adding some functionality. Okay. So let's define a function. And as we learned about the first class functions in Python, so this function will take a function as an argument. And then inside this, we'll have another function. Okay. And here let me print, I got decorated. And after this, what I'll do, I will call the function which we get here. I'll execute this function and then I'll return the inner. Okay. So if you see, we have this make pretty function. So this function takes a function as an argument, and then we have another function inside this make pretty function. So basically we have another function. We have defined another function inner. So inside this inner, we have this function. Okay. And from this make pretty. So now if I say, let me define an ordinary function. Okay, if you can see, we defined 2 functions here. One is make pretty, one is ordinary, correct? So in here, if you see in make pretty, this function takes function as an argument and it has another function inside it. So inside this function, this inner, I'm printing this I got decorated to the console and I'm executing or I'm calling this function, right? So when I call this function, it will return me this function. And when I execute this function, basically this part of the function will get executed. So now let's say decorated func is equal to make pretty, and here I'll pass the ordinary function. So if I run this code, oh sorry, I need to execute this function. So you see, what I did in line number 12 was I used this make pretty function. I called make pretty function and I passed this ordinary function as an argument. As you remember, we studied about this in the first class function. Here we had this grid function. This grid function takes a whisper and then inside here it's calling this function, right? So it is the same concept. I have this make pretty function and inside this make pretty function I'm passing ordinary function as an argument. So it goes as an argument here, and here what it does is this function returns me a function. Okay, so this is like same as we did earlier, like this. Okay, but since I need this argument, okay, so I'm placing it inside that function. So here, when I call this function, I'll return this inner function and I'll pass this function here. Okay, so that means if I print decorated func, you'll see this is a function object. You see, so this is a function object. So when I call this make pretty function, it gives me a function object, and in line number 15, I'm calling this function. So this is basically a simple decorator. Let's say I have any type of ordinary function. Let's say I have another ordinary 2, and here what I can say now is I can pass ordinary 2, right? Ordinary 1, sorry. You see, I'm ordinary 1. So if I say here, so let me say Okay, so what's the benefit of this decorator? The benefit of this decorator is, let's say I want to print this learn with Pratap in every function which I execute in my Python project. So now wherever I want this learn with Pratap, what I would say is I will use this make pretty decorator function. Okay, so if you can see, like in this case, we are passing the ordinary function as an argument to the make pretty, like we are passing this as an argument, and the make pretty function returns the inner function, and it is now assigned to the decorated function here. So when we finally call this decorated function, the inner function gets executed. Correct? If you can see, we have this I got decorated first, and then we get I am ordinary. Okay. So in short, a decorator function takes a function and do some decoration, a bit of like it changes its functionality a bit, and then it returns a function again, right? That means, let's say I want to add 2 to each of the function who calls that function. Then in that case, I'll use a simple decorator by adding 2 into it, and so on. So we are currently learning decorators in Python. So in the previous video, we learned about how we can use a simple decorator. So in this session, we'll learn about how we can use this symbol. You can say symbol. Okay. So using this, how can we use as a decorator in Python? Let's learn about it. So here, instead of assigning, like what we did over here was, we use this make pretty function and we are assigning to a variable, right? Decorated function. So instead of doing that, what we can say now is, let me define another ordinary function. Let's say I'm ordinary 2, and let's say ordinary 2. So now instead of calling the make pretty function and passing this ordinary function as an argument, now I can simply use this and I can say make pretty. Okay. So now when I use this and make pretty, so this means that I'm assigning some decorated function to this, basically function ordinary 2. So let me comment this, and let me comment this, and let me run this code again. But since we didn't call the ordinary function, nothing happens, right? So here we define to a variable and we are calling this function, right? So now I can directly call this ordinary 2. So I can say ordinary, and I can call this function. So when I call this function, you see it says I got decorated, learn with Pratap, and I'm ordinary 2. If you see, my make pretty function is here. I hope I'm making sense. Okay. So here the ordinary function is decorated with the, like this ordinary 2 function is being decorated by using this make pretty. Okay. So how are we decorating? Like when we were decorating this function here, we were decorating this function by calling the decorator function and passing the function as an argument, and we're assigning to the variable. And then after that, we were calling that function, right? But here, instead of doing all these hassles, we were able to do it by just adding this make pretty on top of that function. So having this, just this, and having all this is the same. Okay, simple, right? So now let's learn how can we pass functions with parameter. Like I don't have any parameters right here, so we can have some parameters in this function also, right? So how can we use that? So for that, let's say we have another function, let's say divide. Let's define a function divide, and this will take 2 arguments, a and b, and then we'll return a by b. Okay. So if you remember, we learned about exception in the previous sections. So if we divide any number by 0, so in that case, it may throw exception, right? So like either we have to use those try except block, or we can use a decorator. Okay. So let's have a decorator. Let's define a simple decorator. Let's say def smart divide, and it will take this function as an argument. So we have this inner function. So it basically says I'm going to divide a and b, right? So here what we can say is we can check the value of b. If the value of b is 0, then in that case we will just return by saying that we cannot divide. Okay, let's do that. So you see here, we have this smart divide. So we defined a decorator function. So it will take function as an argument. Okay. So inside this, we have another function. We define another inner function. So this inner function will take a and b as an argument, and it will say we are printing I'm going to divide a by b, and we are checking here if the value of b is equal to 0. If you remember, if we try to divide any number by 0, then in that case, it would throw an exception. So here what we'd say is, if the value of b is 0, then in that case, we say print, we cannot divide. Okay. And then we return, we don't execute the function. And after that, if the value of b is not equal to 0, then we return the function by passing the input a and b. And then from this decorator function, we are returning the inner function, right? So let's call this. So now let's use this divide. Let's call this divide. And let's pass 2 arguments, let's say 7 and 0. So let's run this code. So it throws an exception, right? So now if I use this smart decorator, okay, and if I run this code now, it doesn't throw any error, right? So why is that? So I forgot to use the f string, my bad. Okay, so this way we are using this decorator and we're able to handle the error, right? So this is the benefit of using a decorator. So far we have learned about different type of decorators, like how we can use decorators. We also learned how we can use this @ symbol to decorate a function and the differences it brings when we use this @ and without @. So we need to assign to this variable. And we also made a smart divide. Oh, this is some typo here, so it should be smart divide. So we created a smart divide decorator function, and then we were able to handle the 0 exception, right? So this is the benefit of decorator. I hope you will learn about this decorator. So the easiest way to learn all this is by doing a practical or coding along with me. So if you do that, I guarantee you will be able to learn it more quickly. Hello, welcome back. So in today's video, we'll learn about mutability in Python. So let's get started. Let's understand about mutability in Python. So in Python or in any programming language, we have this two terms called mutable and immutable. Mutable means it is liable to change, and immutable means it is not liable to change. You can just define from this: immutable, it is not liable to change. So in Python, string, integer, float, these are immutable. Okay, so they are not liable to change. And list, etc. are liable to change. Okay, so how can we say that? So first, let's have a variable a equal to 10. Let's assign b to the variable a, and let's print the id. So in Python, we can use id to print the location of these variables. Let's say id of a, and let's say id of b. And let's run this code. So we see the address of this, both the variables are same, right? So now let me change the variable of a is equal to 13, and let's print the id again. And let's run this code. So let me enter like this. So let me run this code again. So you see, so when I say a equal to 10 and b equal to a, so that time at that moment the address was same for both the variable a and b. But then when I reassign the value of a to 13, so after that it got assigned to a new location. So this is called immutability. That means it's go and change to a new location. Like the value is changed in the new location. It's updated in the new location, which means that integer and float are immutable. Okay, so let's take an example for string. My name equal to Pratap. So now I can say print. So I can print the second index of this string, right? So it will be a. So if I run this code, so you see we get a. But now instead of doing my print equal to my name, so let me use the same command, and I want to convert this a to value of string t, and let's try to print the my name. And let's run this code, and you see we get an error. That means string object does not support item assignment. So this means that I cannot reassign or I cannot change the value of this string. So if I want to add t to it, so what I have to do is I have to entirely set a new, assign the variable my name equal to, oh, this is still valid. So if I run this code now, you see, so that means I can reassign the variable, but I cannot change the value in that variable. Okay, so let's take another example for list. Let's say my list. I have 3 items in this list, and let's print the id of this list. Okay, so now after this, let's change the value of 1, like the first index, like let's say this 1 to 10. Okay, what we can say, my list of the first index is equal to 10, let's say, for example. And let's print the id of this my of the my list again. Also, let's print my list. Let's print it here as well, and let's run this code. So you see here we have the item in this list are 1, 2, and 3. The location of this address, the address location was this. Okay, and I changed the first index, item in the first index from 1 to 10, but the address remains the same, right? So that means I can change the value of my list. So this is also immutable. Like for the same example, let's take a tuple. Let's say my tuple, and let's say I have 1 and 2. Okay. But if I run this code, so you see, we cannot change the value of my tuple as well. So my tuple is also immutable. We can add tuple, right? So what have we learned in this immutability in Python? Mutable means liable to change. Immutable means not liable to change. So string, int, float, etc. are immutable. So tuples also is immutable. we cannot change the tuple, and list is mutable, and we tried by changing the value of a like this, and we tried by changing the string, and also we tried by changing the list and the tuple as well. As you understand, the benefit of this mutability is we know what will change, what can change, and where it can change. So using that, we can write our code in such a way that it doesn't affect us, right? So I hope you find this helpful. So far we have learned about mutables and immutables. So in this session, we'll learn about what mutable default parameters are and why is it a bad idea. So let's get started. So here, if you can see, we have a student class and we have this constructor. So when initializing the student, we have this name and grade as a parameter, and then we're assigning it to the attributes of this class. Okay. And then you can see here, we have assigned a grades a default value of empty list. And you can see here, I have added, it's a very bad idea, right? We'll see why is that. And also we have defined a method here, take exam, which takes a result as an argument, and we append that result to the grades. Okay. So here I've created a object of this student and I passed name here, Pratap, but I didn't pass any grade here. Okay. So if I don't pass any grade here, so it will take this default parameter like default empty list, and then here I have called this take exam method by passing 70, and in line number 14 I'm printing the grades of this object Pratap. So let's run this code, and you see we have 70 being printed, right? So now let's create another object. So let's say the name of this object will be Raju. Let's say Raju. But let's don't give any exam, like this object, this student was absent, so he didn't give exam, so he'll not have any marks. So now let's go and print his grades. Okay, let's say Raju.grades. So what do you expect the result will be here? Please pause for a moment, check this. Okay, so let me run this code. We get 70 and we get 70, but this user doesn't give any exam, right? But why did we get this 70? Strange, right? So let's try to print the address. So in order to print the address, we can use this ID function. So let's use this. Also, let's write here ID. And let's run this code again. Strange, right? It has the same memory location. Why is that? It is because when we create this class, when this class got created in the Python compiler, what compiler sees here is grade is being assigned to an empty list. When this class was set with something, when it was set, like it was run somewhere or compiled somewhere, so this empty list corresponds to certain location in the memory, right? So we say that if the default value of grade would be empty list. So in that case, what it says is whenever we initialize the object, so at the time it says that the default value would be that particular address of this location. So it should be somewhere in the memory. So what it assumes is that this empty list is actually the default parameter, right? So let me run this code again. So you see, each time I execute this class, each time an object is being created, we have this new location, right? But both of them corresponds to the same location. So what can we do that? So how can we overcome this type of problem? So instead of assigning empty list here, what we can say is, we can say a default value should be a none. Okay. And now here, while assigning the attributes here, now what I can say, if there is grade, then grade, or we can say empty list. Okay. So if I run this code, so you can see we have different location right now. So let me remove this ID again in both of them. And let's run this code again. So now it works as expected. So what we should know is we should never have a mutable as a default parameter. Otherwise, our program will be very bug prone and it will be very difficult to debug. Okay. So in this session, we have learned about how the mutable default parameter can affect our code. And we also see how they were referencing to the same location in the memory. And we also learn how we can avoid such problem. So we can avoid it by saying equal to none. And if the grade is empty, in that case, we can assign the empty list. Okay. Also, let's try this with the name parameter. Let's say by default name would be equal to an empty string. So in that case, let's not pass Raju here. And then let's try to print Raju. Let's say Raju.name. And if I print this, you see we don't have the name. It's empty. Okay. I hope this makes sense. So I hope you were able to understand why we should not use mutable as a default parameter.